begin today's
conference will
webinar.
now be recorded.
Okay, I really appreciate you all for attending today's webinar. A very good morning, afternoon, and evening to one and all present here virtually with me today. Let me introduce myself. My name is Resina, the Conference Secretariat at Coalesce Research Group LLC, and I will be available throughout the conference for any of your queries or questions to help you out technically and organize the webinar successfully. For the next 5 minutes, please allow me to give a brief description about our organization, Coalesce Research Group, and also for the further instructions. Coalesce Research Group LLC is very delighted to welcome you all the speakers, supporting associations, students, delegates present virtually with us today. With the aims mark the scientific excellence by facilitation conversation, sharing knowledge, Coalesce Research Group follows through the objective of setting standards and delivering the excellence in the research among the researchers, academicians, and industries. Promulgating the research throughout through the conducting events and online webinars from various fields of science, especially from the stream of medicine, science, engineering, and technology. Within a short duration, we have succeeded in creating a platform for developing a strong professional network with the people across the world from their respective fields that they haven't connected in a while. As a global scientific event organizer, we plan and carry out international conferences, meetings, seminars, symposium, and workshops, providing the best delegate experience, excellent networking opportunities, conversations leading to innovations, learning new opportunities, lasting working relationships, and professionalization with the professionals across the global network. Just recently, we have also started our own platform for open access peer reviewed scholarly literature, where all the content is freely available without any charge to the reader. We aim to share the new recent advances through scientific publications, which will help in minimizing the borders and contributing the use of research works, research scholars, students, etc. across a broad spectrum of medical, clinical, pharma, and engineering scientific disciplines and its subspecialties to promote the ideas which will guide the development and facilitate the use of scientific information and ensure its quality, and also will be the connecting link between researchers and scientific community. We are committed in ensuring that our journals are disseminated worldwide so that the researchers are able to access our content wherever and whenever possible. We will also send you an email with all the details about the journal after the commencement of the webinar. Do take your time to check it on the website. Finally, I would like to thank all the attendees and participants of today's webinar and hope you enjoy this and gain some knowledge from the session. We also hope your participation will contribute to new research findings and that will lead to new collaborations and research initiatives. Before we start with the sessions, I guess some of you will be new to the GoToMeetings app. So I will explain you the process. On the GoToMeetings app or web page, you can find 4 icons at the bottom of the center of your screen: mic, camera, screen, and leave. Mic, click on that to mute or unmute yourself. I request you all to stay muted while our speakers are presenting their research so that it doesn't cause any disturbance to them. Camera, you can use this button to share or unshare the webcam. If you have the option to share the webcam, you can do that, or it is completely your choice. Screen, you can use this button to share your screen. This is the main part during your presentation. After I call your name from my side, I will be making you the presenter, and only I give you the permission, you will be able to share your screen. So once I make you the presenter, you can click on the screen button and you will find a pop-up window to share your screen. And leave, this is your fourth icon where you can use this to leave your session. So at the top right corner, you will have 3 icons. Please, people, chat, and settings. In the chat option, you can chat with me and everyone. So as mentioned, kindly remain muted during the presentation. So, well, let's not take much of your time. Finally, I would like to thank all and request you to please give a brief introduction about yourself before starting the session. so that we can know about you virtually. Now let's move into our sessions. So our first session is presented by Dr. E.V. Daniel Tay from Nanyang Technological University, Singapore. Hello, Dr. Daniel.
Hello.
Are you ready with your presentation?
Sure.
Yes,
Maybe you
I'm
can give
going
me
to make you
permission.
the presenter. Just a minute.
Okay.
Yes, you are the presenter now. Please share your screen with us.
Okay.
Yes, perfect. Now we can able to see your screen. You can start presenting.
Okay. Hi. Good day, everyone. I'm a research fellow from NTU. Currently working on 3D printed concretes. So today the topic I'm going to share is the sustainability of using recycled glass in 3D construction printing. This is going to be the content. I'll go through some introduction. Then I will share the sustainability impacts and the challenges of printing with recycled glass. I'll show the gradation of different aggregates such as natural sand and recycled glass, and I'll show the results of us printing the recycled glass. Then finally, I'll conclude. Okay, so for sand have been used in construction for thousands of years. Yes, it provides a bulk and strength. The current rate of sand mining operation is considered as non-sustainable as the rate of mining exceed the rate of natural renewal. So we know that sand mining destroy habitats, it dirty the rivers and erode beaches. So many of which are already losing ground to rising sea levels. So when miners dig out layer of sand, riverbank become less stable, and the pollution and acidity can actually kill fishes and leave less water for peoples and crops. So the problem is made worse when dams upstream prevent sediments from replenishing the rivers. So this is a Semakau landfill. This is Singapore's only landfill, and actually a lot of money is pumped into to create this in 1990. And its lifespan is actually projected to end in 2035. So in order to prolong this landfill, we need to repurpose the waste material going there, and repurposing waste material can actually help Singapore to attain its goal towards a zero waste nation. So one of the waste material that has low recycling rate is glass, and glass has a recycling rate of approximately 14 to 20% due to its complexity of recycling it. Sorting the different glass material can actually be a tremendous effort as compared to dumping it into the landfill. However, sand is a non-biodegradable material, and the property can be suitable for concrete aggregates. So conventional concrete methods takes a lot of time to construct the formwork. So before concrete can be poured inside, the current method of construction also is very so 3D printing, also known as additive manufacturing, it's to construct the object in a layer by layer manner. And in order to print the object, we need to design a CAD model and generate the print path. So as we all know, there are many advantages in 3D printing. Few of them are increasing productivity, greater customization and complexity, produces less waste, reducing costs, and also no formal is required. So at the end of the printing process, we actually carry out post-processing to improve the mechanical strength or improve the surface finish. We can actually grind the surface or use a metal reinforcement to reinforce the printed item, depending on the application. So due to these benefits, there's a spur and increase in the trend in the research for additive manufacturing and building construction. So the challenges of us to achieve this, we wanted to solve this environmental issue by combining it with advanced technology to achieve a sustainable and effective construction. So in some preliminary studies, we have difficulty trying to extrude the material due to the sand, the glass actually clogs the holes. This can be attributed to its irregular shape of the glass that could resist in the motion, or could be due to the different type of size or gradation of the particles. So what we wanted to achieve is to study the sustainability impacts of using such aggregates and to explore the mixed design for 3D printable concrete. Right. What we will do, we will evaluate the sustainability impacts based on environmental and social impacts, examine the mechanical strength of the concrete mixtures, and also analyze and calculate the results. So first, to investigate the sustainability impacts, we actually go through the environmental and social impacts. The definition of sustainability is the act of living within the constraint of the existing physical, environmental, and social resources while meeting our need without compromising the need of future generations. The environmental sustainability is we should be responsible to conserve natural resources and maintain global ecosystem in the present as well as in the future. So as mentioned earlier, the rate of aggregate extraction is far exceed the rate of renewal. So sand can be extracted from rivers and lakes, and it can be detrimental effects in the environmental, such as destroy marine ecosystem, loss of aquatic and forward geomorph deformation. So below I will show two real world examples. Right, this is a lake in China, Poyang. As shown in the figure, there's an effect of a widening of the lake, and this effect is quite obvious. Such widening of the waterway increases water flow, draining the lake, making it more vulnerable to droughts. Another case study is the Mengkok River. So sand extraction actually caused the river level to be lower and cause coastal erosion. This can also cause reduction in fish stock and drying up of breeding grounds. Right, here's a list of other negative environmental impacts on sand mining. Okay. So now that we know that unsustainable sand mining has much negative effects, we should find alternatives to replace the use of sand. And on the other hand, we can prolong the landfill if we were to repurpose glass waste. And the use of glass waste will reduce the carbon emission created by the delivery of the sand from other countries. So using glass that is locally produced can reduce carbon emission caused by delivery. So the next part is the social impact. This is the identification and management of both positive and negative business impact on people and social life. So over here, you see there's several countries that are already gradually banning sand from exporting to other countries. Right. These are the countries that ban exporting of sand. The ban on the sand export is mainly caused by the environmental damage that the government acknowledges. Okay, so there are much social impacts that that can occur. There can be conflicts between miners and fishermen due to the fact that mining activity will cause destruction to the aquatic organism. Right, corruption can also take place as illegal mining continues to take place and sand is smuggled. Right. So now that we've understand the sustainability aspect of sand mining, we'll proceed to right. Need me to show my camera? Can you see me? Resina, can you see me? Right, maybe let me continue. So now that we've gone through the sustainability aspect of the sand mining, we'll proceed to attempt to print the recycled glass, and the properties will be compared with the river sand. So microscopic analysis is actually conducted with the two different type of aggregates, sand particles and also the recycled glass. right? These images show that both of them have irregular shape, but then the river sand has a rougher surface texture as compared to the glass aggregates, and this can increase the interparticle friction and increase the static yield stress and passive viscosity. However, the sharper corners of the recycled glass could also reduce the fluidity of the mixture. And another observation is due to the rougher surface, actually the sand particles can have a higher water absorption capacity than as compared to the recycled glass. Over here shows the sand gradation and the recycled glass gradations. As you can see over here, the red one, which is the 100% sand, this is actually much steeper than the recycled glass. So which means that actually there's more fine particles in the sand as compared to the recycled glass. We got our samples from EnviroSand. They are able to give us in 3 different types of sand gradation, and we're able to mix the ratio as and when we like it, so that we are able to ensure that the material is printable. So in this study, we'll be investigating the mechanical properties, which includes the compressive and flexural strength. There'll be different mix ratio, 0%, which means a replacement of 0% recycled glass content with sand ratio. So as the percentage increases, there'll be more recycled glass in the mixture. For the compressive strength, we actually printed and casted a 50 mm cube sample. For the printed sample, we actually print near net shape. However, due to the uneven surfaces, we have to actually trim the surfaces down to 50 mm cubes. This specimen actually is loaded in 3 different directions to investigate the anisotropic properties. For the flexural strength specimen, we also printed it to near net shape and tested into 2 different directions along the filament and across the filament interface. So this is the results that we obtained. They actually, so as the recycled glass increases in the sample, there's actually higher strength as compared to the printed samples. So over here in this study, we also noticed that in the loading direction, there's really no significant effect on the compressive strength of the printed specimens. A similar trend is also observed in the fracture test. So the strength actually reduces as the recycled glass content increases. However, it's also interesting to note that the flexural strength of the printed samples is actually higher than the casted samples in both directions. So with these results, we are able to create the mix design, and we are able to print several items. Over here, it's a printed steps tool, right? Can be used as a bench, or it can be used as a steps tool. Right, over here, we've printed a few more items. We've printed a curve wall, right? The curve, it's initially, it's first few layers, it's curved. Eventually, you will change to a straight wall on top, right? The other one, it's a printed vase. This is approximately, I think 0.5 meter, 0.5, 0.6 meter. Yeah. So to conclude, we actually investigated that recycled glass is proven to be feasible to be printed, right? The increase of the recycled glass content reduces its compressive and flexural strength. This can be caused by its smooth surface, which reduce interparticle frictions. And we can see that there are actually some filaments that were printed with less cracks and discontinuities. So, and the replacement of this using these sustainable materials actually reduce reliance on our sand supply, and also allows environment to replenish loss of sand, and it can be we can actually repurpose this material and reduces waste going to the landfill. So some future work that we can do is to study the different water to binder ratios and aggregate to binder ratios, right? Design of aggregate grading and then improve the strength, and also to study different type of additive to improve the performance of the material. Yeah, that's the end of my presentation.
Thank you very much, Dr. Eve Daniel Tay.
Thank you.
So if any queries,
Any-
please go ahead.
Any questions?
I think there are no questions.
Okay.
So we will move on to the next presentation. So
Right.
next
Thank you so much.
presentation is by Dr. Kristina Sukova from Tridas, SRO, Czech Republic. And the presentation title is Demonstration of Packaging Product Solutions Based on Transformed Hop Waste.
Okay, hello everyone.
Yeah, hello.
Do you see me?
Yeah, we can't see you, but we can hear you.
Okay, but I
Just click on the
have
camera.
yeah.
Yeah, we can see you.
Hi everyone.
Yeah, hello.
So my presentation. Okay. Mm, I have quite a problem with my share screening.
Yes.
I don't know why. I have the information about to share your screen. Ask the organizer to make your presenter. I don't know.
Yeah, hello
Yes.
Christina. I have made you the presenter. You can share the screen now.
Okay, thank you.
Yeah, we can see the screen now.
Okay. Mm. I don't know.
Yes, we can see your slides.
Okay, but I I don't know if the share the whole.
We
Fine now.
can see your slides
Fine now.
perfectly.
Yeah, it is fine now.
It's very fine.
Okay. Okay. So I'm from Tridas company from Czech Republic. Tridas company is a producer of 100% recycled molded fiber packaging. Is the located in Czech Republic, is the European leader and producer of I'm sorry, I can I said. Recycled molded fiber packaging and production lines for molded fiber technology. The molded fiber is an ecological packaging material with tradition and future. We are using renewable resources in production lines like recycled materials, old newspapers, cardboard waste of cuts, virgin pulp or recycled input raw materials like agricultural waste. So this is waste from hops. Every used material is environmentally friendly. All molded fiber trays are 100% recycled and recyclable, biodegradable, and CO neutral. On the next slide, you can see the input materials which usually used in Tridas company. The one is virgin pulp. On the picture 2 is cardboard of cuts, and in the picture 3 is hop waste. The next slides show the Biotop project. It's the information about objective, biotwine hop waste transformation into novel products assortment for plastic and horticulture sectors. The next objective is implementing the new circular economy fruit action, spanning the value of the hop biomass after harvest. The next is introduce a biodegradable and home compostable PLA twines into hop growing industry. The next is extracting natural fibers from biomass after harvest and use them in. The next is importing for Tridas is fully biodegradable materials, wine bottle packaging trays, and planting pots from other companies within project Biotop. Use also for hop seedlings growing. Quality valorization of the compost is the next objective of Biotop project. As you can see the circular economy of the Biotop project. This is the next slide shows the objective of project for Tridas. This is the adaptation of hop waste scraps into pulp molding process, developing of wine bottle packaging made from pulp and hop waste material, recovered and modified hop waste fiber scraps within the live project Biotop. The material is from Zelto technology, one of the project's companies within. The next objective for Tridas within the project is it is support a circular economy in the hop industry. This slide shows the material testing from without PLA from Zelto technology. Testing material in different combinations of input materials. So we used hop waste, cardboard of cuts, and virgin pulp. As you can see, the first step of testing was microscope testing. So as you can see, testing started by microscope view to see fiber span and the differences in fiber length, and continue the test to see how the material will hold together. First microscope picture is shows modified 100% pulp hop material, which is not perfect to packaging at all. All the picture shows various percentage of the hop waste material mixed with cardboard, which is normally used in Tridas for packaging. This is the 50% of hops and 50% of cardboards. The next picture is 30% of hop and 70% of cardboards. and the last picture is 20% of hops and 80% of cardboards. Material testing was first step of material testing was mixing with water. This is the dry condition and mixed with water, and then I'm sorry. And the second step and first step was testing. The wet condition and dry condition was testing. In the next slides, you show you can see you can see the pictures shows the difference in fiber thickness. Using input materials were hop waste and cardboard. The less percent of hops additive, the fiber is better for production of wine bottle packaging. There's another picture that shows you the material testing. 100% fiber, hop without PLA, 90% cardboard, and 50% fiber, and there is a zoom the 50% of hop. Yes. One of the one of the material testing characteristic is the material stability. The biggest differences in this stability is fiber length, fiber thickness, and material stability. This is, as you can see in the pictures, one is fiber, the two is 70% hop and 40% fiber, and the last one picture is for 100% hop. In the table below, you can see in what combination the input material were mixed. In addition to hop-based material without PLA, cardboard offcuts and virgin pulp were also used as input material, which are normally used in traders for the production of molded fiber packaging. During the whole testing process, our team of designers have been also working on 3D design. 3D design was designed according to general wine bottle measurements. We decided to use bottom part with top one with sophisticated details, which will ensure safe packaging for the wine bottle. This is just the draft on the design. 3D design was developed to final version with top and bottom part, so tray is closable. This design was done as universal, so it will be suitable for any types of wine bottle. In this slide, you can see the production process. The production process is producing on conventional line, as you can see in the picture. First step of this process is mixing collecting waste paper, cardboard, and newspapers mixed with waste material and the hydropulper. Here the material was mixed with water, and within 15 to 20 minutes it was the fiber to establish pulp. This mixture was pumped through two-stage filtration, where in the first cycle heavy impurities, small stones, sands, paper clumps are separated, and in the second cycle in light impurities are separated. Pure pulp was stored in tanks and ready to subsequent use. The last step of the pulp preparation was its mixing to reach required operations parameters. The second production steps was to pumping of pulp of the forming section on the line, where it was sucked onto aluminium molds. This was then shaped and the desired form, and after the residual water has been exhausted, the finished products were transferred to the drying belt. The drying process was automatically monitored. During this process, the humidity, temperature, and volume of drying air were controlled. The wine bottle tray drying times range about 40 minutes. Subsequently, the dried trays were collected and the basic quality characteristics were checked. It was possible to see at a glance of the resulting products which of the tested combination of input materials was more appropriate to use in production and more suitable for packaging. This is the result of the molded fiber production. Molded fiber packaging trays production. This is just 100% hop-based material, and this is the 70% hop-based material. It cannot be made from 100% hop-based because the consistency of used material does not hold together, and it got really stuck on the testing form. The trays has been torn and didn't hold the shape. In the 70 hop-based material and fiber showed better results, but it wasn't ideal for wine bottle packaging, as it got stuck on the form also, but the stability was better. So in the production plan was to use as much hop waste as possible, but as it turned out during production, the more hops used, the more unsuitable the resulting products were. The ideal combination of materials was carried out 50% cardboard of cuts and 50% hop waste. This combination of these were determined to be the most suitable and final one. The stability of the material was defined as the greatest, and there was no visible handling problem during the wet or dry phase on the production process. There was minimal spoilage during production. This is a pair of pictures. You can see a forming of trays, 50% hop waste and 50% cardboard, and transferring to the belt. On these pictures is final products coming from the oven, quality checking and collecting by our employees. Final products being stacked together and placed on the pallets. Next step of the production of packaging trays is validation. Trays was made from 50% hop waste and 50% cardboard. Within validation process, where testing has testing the combinations and has been verified as ideal combination of materials suitable for our production process. Based on developed free design, tooling was made and 1,000 pieces of packaging trays were produced and passed ISTA-3A testing. Manufactured wine bottle trays were subjected to regular use and were testing on the heat resistance, condition properties, mechanical properties, physical and climatic properties within the validation process. The validation process also of the trays was subjected to 3A ISTA testing, which tested the protective effects of the packaging under transport loads in the supply chain, and cardboard box was required for this testing. For this testing was used cardboard box with eternal dimensions 400 to 100. Okay. During ISTA-free testing by the actions foresees were caused only particular damages on the box after the shock drop, only significant defects on the trays. The whole unit itself remains without any kind of damages or defects. Packaging provides sufficient protection and fixation of the unit side. So the result of ISTA testing based on protective packaging components was the wine bottle tray successful passed this test. So tray was officially validated as proper protection for wine bottle packaging. This in the pictures you can see the final product, wine bottle tray packaging, and this is you can see the partners of Biotop project. Okay, thank you for your attention.
Thank you very much, Dr. Christina. If any queries, please proceed.
Ja, neću bunke.
Do you have? Okay.
I hope there are no queries. So we'll move on to the next presentation by Dr. Barbara Se from Slovenian Institute of Hop Research and Brewing, Slovenia. Presentation title is Composting as the Best Way to Introduce Circular Economy to Hop Production.
A ja butlele, kad misliš? Hello, can you see and hear me? Hello? Okay.
Can see and hear.
Hello, Dr. Barbara. We can see you and we can hear and we can see the slides as well.
Okay, thank you. This is my presentation with headline Composting as the best way to introduce circular economy to hop production. Around 2,600 hop farms cover 26,500 hectares of land in European Union and produce over 50,000 tons of hop cones per year. Slovenia is the world's sixth largest hop growing country, accounting for around 1,500 hectares. During hop harvest, plants are cut and the whole above ground biomass is taken from the fields to the harvest machine. Dried hop cones are the main product for the brewing industry, where the raisins and essential oils from cones are used for beer aroma, bitterness, and stability, whereas a surplus above ground biomass after the harvest, that are hop leaves and stems, accounts for 2/3 of all harvested biomass. While cones are harvested, dried, and packed, stems and leaves are left next to the harvest machine as a byproduct. Every harvest season, the hop industry in Slovenia generates over 15 tons of waste hop biomass per hectare of harvested hop fields, resulting in 22,500 tons of green waste. The problem is plastic twine that serves as a support for climbing hop plants during the growth, which after harvest stay intertwined in the biomass. Oh, it's not moving.
Yeah, just
okay.
click on the next.
Yes, in recent years, farms have been facing the challenges of managing and disposing of green biomass. There are uncertainties what to do with these huge amounts of biomass. We must not dispose it in illegal dumps, dispose outside in nature. It is prohibited to burn it in the natural environment and also to give it to unauthorized persons. Within the EU LIFE project BioHop, we were trying to find solutions for introducing circular economy in hop industry to solve these questions. We introduced biodegradable and compostable twine as a support for hop plants on the field. So the biomass after harvest became an important raw material for composting this biomass. The twine degrades in proper composting conditions to water, CO2, and organic mass in some months, namely. And the biomass is suitable also for pellet of biodegradable products made from hop fibers extracted from this hop waste biomass. One of them was shown to you in the previous presentation. Although these all new ways of using hop biomass after harvest are being investigated, composting still remains the most promising in terms of utilizing biomass, which would be a good solution to the end of nutrient cycle on hop farms. We can pay an industrial composting site to compost this biomass, or on the other side, there is possibility to do this composting on farm. On-farm composting could be an efficient, cost-effective, and environmentally safe biological process for the recycling of residual agricultural biomass. This is an exothermic decomposition that depends on material mixture, moisture, volume, material composition, pH, particle size, and their distribution, mixing, and also aeration. However, we have to be careful to obey all regulations even before we start to compost on farm. There are several rules that we have to follow not to be in conflict with regulation and also to behave environmentally friendly. It is important, for example, to know that the compost on one farm can be made only with biomass from that same farm, and that we have to use the resulting compost on the same farm. Hop biomass after harvest is a waste until it is processed into compost, and then it should be sieved so the remains of polypropylene plastic twines are removed. We have to pay for procedure, and also we have to pay that authorized person take the plastic part to landfills. Because of all these problems, we introduced biodegradable and compostable twine in hop growing. It is made from polylactic acid, and it was improving during 3 growth seasons. The twine should resist the weather conditions outdoor. It has to resist hop biomass and strong winds, maybe, and also spraying. If we use biodegradable twine for hop plant support during hop growth, the final compost of such biomass can be used without sieving, because there are no remains of plastic in it. We avoid expenses for sewing and also for landfill. We have made extensive trials with hop biomass after harvest for 3 years during the BioHop project, and on this basis prepare technological guidelines on how to implement the procedure of composting to prepare quality and safe compost. It is meaningful to use compostable twine, as we mentioned, and it is necessary to make the pile in a right way. So not too high, not too low. It has to be in trapezoidal shape. Particles of hop stems and twines are made small at the start of the process. We have to mix the pile according to the temperature measurements and keep the moisture right, as well as cover the pile at least 5 months after start of composting and keep it covered up to the end of the composting. With such a procedure, we get the compost at the end of the season, at the end of the composting season, so in the next spring, which is full of nutrients. It contains organic mass, organic matter. So with this, we can buy some less fertilizers that necessary. If we have a look of the temperature dynamics in 3 different compost piles, you can see here on the upper picture, we can see that different protocols. So we use different particle size of the start organic matter, different additives and composting treatments. And this all played an important role in this temperature swings, as you can see. The hygienization standards were met in all piles as the temperature reached over 55 degrees in all of these 3 piles for more than 14 days. Elevation of temperature in all piles indicates that we need at least 15 tons of hop biomass to start this process, that this is enough. This is the biomass that we get from 1 hectare of hop field for approximate, so you can imagine. So this is enough to start the composting process. We can also see that a certain combination of parameters can affect it in a way that temperature gets even over 70 degrees Celsius. Such high temperature is not desirable because it can limit the diversity of microorganisms and also slow down the composting process. So we have to be careful what parameters and what procedure we take to get not to get this too high temperatures, and also to get at the same time the temperatures are high enough, so over 55 degrees Celsius. Because at this temperature, the hygienization of this biomass starts, and also the degradation of PLA twine. Here on the right side, right bottom side, you can see average properties of final composts made of hop biomass. There were significant differences in these parameters also, but we found out that hop biomass is a excellent starting material for compost to get final compost good in a way to use it as a fertilizer. And also, I have to mention that the PLA twine was degraded in all these compost piles fine. So after 6 or 7 months of composting, we found no leftovers of this twine in the compost. If you are interested in more results from our experiments, you are welcome to visit our public media, so you will be directed on papers and videos that we have made during our project, which is still going on. Thank you for your attention.
Thank you very much, Dr. Barbara. So please go ahead if there are any queries. I hope there are no queries. If any queries, please mention in the chat box. So
Okay,
we'll move
I
on
will
to
see the chat box later if there are any some questions.
Thank you very much, Dr. Barbara, once again.
Yes. How can I close the presentation?
Yeah, I'll make the presenter for Susanna. Automatically, it will get closed.
Okay. Thank you. Goodbye.
Thank you. Yeah, bye. So next presentation by Dr. Susana Lozano Calvo from University of Huelva, Spain. The presentation title is Comparison of Different Double-Stage Biorefinery Schemes on Eucalyptus globulus.
Hello.
Yeah, hello, Dr. Susana. You can start your presentation.
Can you see my presentation?
Yes.
Okay. Hello, my name is Susana Lozano. I am chemical engineer and I PhD student. I currently work at the Productive Research Center of the Chemical Engineer Department of the University of Huelva. The work that I am going to present today too is the comparison of different double-stage biorefinery screen of Eucalyptus globulus. One second. Oops. Ay. ¿Por qué no va? To begin with, it is necessary to comment on the starting point, which is that paper mills have to face a series of challenges. The main ones being the increase in production costs and environmental legislation. Therefore, new technologies must be developed that are less polluting, produce less waste, and allow efficient use of material and energy resources. At the same time, the forestry sector adopts new methods to add value to fractions that were previously disposed of as waste. These two trends have converged in biorefineries process. The extraction of hemicellulose from lignocellulosic materials prior to pulping and their conversion into value-added product is a key biorefinery technology. The efficiency of the technology depends largely on the pretreatment operation, whose challenge is to extract a significant amount of hemicellulose without negatively affecting the quality and quantity of pulp in paper mills. Lignocellulosic materials are a basic resource for sustainable development. The biomass refinery approach is based on the selective separation of the main components, cellulose, hemicellulose, and lignin, which allow their use separate for defined purposes. In biorefineries, the raw material undergo successive processing stage, achieving a comprehensive benefit. For example, in the production of biofuels and/or chemical, with minimal or no waste generation. Physical, chemical, and biological pretreatment are being studied for the fractionation of lignocellulosic biomass and the removal of lignin. Enzymes have proven challenging due to the highly polymerase nature and crystallinity of cellulose embedded within recalcitrant lignin. For paper making, lignin degradation is significant in pulping and bleaching process, but direct use of lignocellulosic enzymes such as lacase, it is difficult because lignin acts as a protective barrier by binding to both cellulose and hemicellulose losses, does not allow any solution on enzymes penetrating. Lacase can be used by the lacase mediator system, which is used for bioblending, but has typically only been used in combination with other enzymes for biopulping application. In a biorefinery scheme, biopulping could be used with another fraction stage, steam explosion or hydrolysis treatment, to facilitate enzyme penetration. Both result in separation of the fibers or physical rupture of the fiber walls. This open structure of the chips could not only increase the enzymatic delignification of the biomass, but also lead to easier and shorter pulping due to the efficient diffusion of the cooking liquor into the fibers. The solubilization of hemicelluloses by hot compressed water hydrolysis processing has been proposed as the first step of biorefinery. This technology leads to a liquid phase rich in sugar or oligomer without causing significant dissolution of cellulose and lignin, and may show greater susceptibility to future fraction. In the present study, 4 double-stage biorefinery schemes for eucalyptus globulus would have been proposed. Common to all of them was a lacase system mediator treatment after hydrolysis. 2 types of mediators were used, whereas 3 types of developed the pulping, so the following were studied: hydrolysis, lacase mediator, HBT or single-headed, plus pulping, soda, anthracic one, organosolvent or ethanol soda. Then some enzymatic and hydrolysis conditions were optimized in order to maximize the extraction of hemicelluloses while preserving the integrity of the glucan. And the pulp obtained in these 4 schemes were compared with those obtained in a conventional pulping process with soda anthraquinone and organosolvent. I will begin by commenting on the general aspect of the methodology used in this work, whose process comprised 3 steps. The first of them was hydrolysis with optimal operation conditions obtained from previous work. This was followed by a delignification step consisting of enzymatic hydrolysis, specifically lacase together with a mediator, which was either HBT, chemical mediator, or single-high, natural mediator. In this case, an experimental design was used. In this table, the normalized operation variable can be seen. Finally, a final delignification phase was carried out, which could be soda anthraquinone, organosol, or ethanol soda, with fish operating conditions. First, I present in this table the chemical characterization of eucalyptus globulus. It has a glucan content of 42.8 which make it suitable for the production of pulp and paper. It also contains 17.1 grams of xylene, which make this material interesting for the industrial production of hemicellulose sugars. We must remember that our main working hypothesis was that pre-hydrolysis plus enzymatic treatment of the raw material allow for handsheets with strength-related properties, similar to those of conventional commercial paper to be obtained and a hemicellulose fraction extracted for additional exploited, all under mild industrial operation conditions, lower chemical load and temperature, and shorter processing time. The proper selection of hydrolysis and enzymatic treatment condition is crucial. Thus, using too strong conditions to extract hemicellulose can result in excessive degradation of the main polysaccharide fraction, cellulose, and in an inadequate comment in hemicellulose in the subsequently obtained cellulose pulp. On the other hand, too mild hydrolysis condition would provide a liquid fraction containing little hemicellulose for commercial use. In the first place, we will focus on the case in which the raw material was subject to hydrolysis enzymatic treatment with the HBT mediator and followed by a soda anthraquinone process. This first table shows the maximum and minimum value of the solid phase properties obtained after hydrolysis and bypass process. Based on those values and the raw material content, soluble lignin is more easily attacked by enzymes. The soluble lignin content in the solid phase obtained was 1.8 to 3.5%. Then it was solubilized between 63.2 to 73.5% with respect to the raw material content. The enzyme treatment yield were very high, and the overall process yield were 79 to 80%. There's variation in the content of glucan and the glaze of lignin depending on the operating conditions can be seen in the following two figures. The highest concentration of glucan in the resulting solid were obtained with medium concentration of mediator and extreme concentration of lacase. In the same way, the Clayson lignin content of the soil was better with low concentration of mediator. The following scheme shows the complete process condition, the three stages of the lignification. Finally, the result of the cellulose pulp are shown, as well as the paper sheet made from it. For example, with the application of hydrolysis and lacase mediator system, it allows obtain considerable lower kappa number, 32.9, than those from unprinted eucalyptus 57. In this case, the results are shown from the third lignification step, since the previous two steps are the same as in the previous case. This first figure shows the operating condition for the complete process, as well as the result of the cellulose pulp and the paper sheet made from it, in comparison with a two-stage process without the enzymatic step. If we focus on the kappa number in the hydrolysis plus organosolv delignification treatment, it varied between 71.84 to 77.6, while in hydrolysis plus by plus organosolv delignification, it varied between 66.1 to 71.4. This is explained by the action of the lacase mediator system that help to degrade lignin, in turn obtain better physical properties. On the other hand, we will focus on the treatment shown in this figure, while this other table shows the maximum and minimum values of the solid phase properties obtained after the hydrolysis and by pulping process on the one hand, and after the hydrolysis process by pulping and ethanol soda treatment on the other. The degree of delignification in relation to the proportion of lignin initially present in the raw material. It is observed that after the stage of hydrolysis and delignification by means of a lacase mediator system between 18.6 to 30.3% have been eliminated. If we consider the complete process after the delignification stage with ethanol soda, the enzymatic stage contributed to increase the total delignification. Specifically, the total percent of lignin removed from the solid has ranged between 70.9 to 76.2% with respect to the initial raw material. In this figure, you can see the variation of the kappa number in the global process of fair values between 39 to 45, while in the case of hydrolysis plus organosul, it had a values between 53.100.7 and compared to the kappa of 60.4, 65.4 obtained in conventional soda and trigonal process. This process is similar to the one I just showed you. Only the last delignification step was changed to the organosul process. In this case, the variation of the creation lignin contained in the solid phase can be seen in this figure, thus presenting a delignification between 69.1 to 72%. The second figure, you can see the variation of the kappa number depending on the different comparison conditions. It varied between 66.5 to 75. Moderate values, considering that the raw material has gone through two separation process of lignocellulosic components. In summary, if we focus on the comparison of the mediator, it is observed that lower yields are obtained with HBT. That is, a greater quantity is extracted to the liquid phase. This translates into greater delignification, which is confined by this last figure. We can conclude that biorefinery of lignocellulosic material allow their full use by allowing various fractions to be obtained with successive treatment. The best results are obtained when working with the HBT mediator followed by the soda tranquinone process. However, the results with the natural mediator are similar to the pulp obtained with the traditional method, but the operating conditions are less aggressive and more respectful of the environment. Thank you very much for your attention.
Thank you very much, Dr. Susana. So, any queries? Thank you very much, Dr. Susana. So, Dr. Klaus Bohnik is joining after 30 minutes. So, I request Dr. Silvana Francisca from University of Naples, Federico to Italy to present now. And the presentation title is Characterization of a tomato genotype able to improve resource use efficiency in water-limited conditions.
Good morning. Oh, okay.
Yeah, good morning. You can share the slides now.
Okay. Sorry. I pre-recorded my video because I have a not stable connection. Wait a moment.
Okay, no problem.
Yeah, hello, Dr. Silvana.
Yeah, sorry, I have a problem with my. I don't read it now because I speak in the afternoon. But if you give me a moment, I speak now. I share now my.
Yeah, you can share your screen. No issue. You can take your time.
Okay, I'm ready.
Yes, so we can able to see your screen. You can start presenting.
Can you see my screen, my presentation?
Yes, yes, we can able to see your presentation. You can start
Okay.
presenting.
Okay. I'm Francesca Silvana, fellow research at the Department of Agricultural Science at University of Naples Federico II in Portici, and the topic of my speech is the characterization of a tomato genotype able to improve resource use efficiency in water limited condition. Considering the ongoing climate change, today temperatures are expected to rise by 2–4 degrees Celsius in the next few years. That can compromise crop productivity in several cultivation areas. Therefore, drought and heat stress are reported to be a major abiotic stresses limiting crop yield. The occurrence of high temperature and soil water depletion can result in a range of morphological, physiological, and biochemical change in plants. Anyway, all the different effects of the two stresses, heat and drought stress, results in a yield reduction. It's important to study the combined effect of the two stresses because high temperature can increase water evaporation from soil and consequently water loss from plants. In particular, we study abiotic stress in tomato plants because tomato is one of the most cultivated vegetable crops in the Mediterranean areas and is known to be sensitive to both water deficit and high temperature. There are different ways to face abiotic stress effects. A useful way is the synergistic use of plant breeding and plant physiology to improve plant performances under abiotic stresses. The analysis of tolerance traits in a controlled condition are necessary in order to reduce the complexity of interaction between genetic and environmental effect on plant phenotypes. So the aim of the present study was to confirm the observed tolerance to elevated temperature of a new tomato genotype E42 by performing a phenotyping under controlled condition compared to one heat-tolerant genotype, LE3120. Moreover, we further investigated the responses of these two genotypes to limited water availability and combined water and heat stresses. This study allowed us to analyze the different strategies activated in the two genotypes in response to single and combined stresses. Starting from the aim, the first step was an ecophysiological screening of different tomato genotypes. A trial was carried out under working plastic tunnel in Battipaglia to assess the field performances of different tomato genotypes cultivated at high temperatures in terms of crop yield and physiological traits. 12 different genotypes were tested under working plastic tunnel with a late transplant to submit plants under high temperatures. Among different analyses done, I reported here yield. Based on field screening, 6 genotypes show the same yield of a hybrid control genotype JAG 8810. And the outcome emerging from this work were the selection of two genotypes, E42 and LE3120, potentially tolerant to high temperature. The two selected genotypes were tested in a growth chamber to investigate the response to combined stresses. LE3120 is a heat-tolerant Solanum lycopersicum, whereas E42 was selected in our lab as a high and stable yielding genotype. The genotype LE3120 is characterized by a medium-sized fruit, while the E52 genotype have small cherry fruits.
The experiment included 4 different treatments. Control treatment with 29, 24 degrees Celsius and full irrigation. Water deficit with the same temperature or control condition, but 50% of irrigation. Heat stress with 34, 30 degrees Celsius and full irrigation, and combined stress with the same temperature of heat stress and the same water treatment, water deficit treatment, 50% of irrigation. The treatment were applied on 30-day-old seedling and lasted for 3 weeks. Considering all the analyzed traits, heat stress had a predominant effect over limited water availability on the tomato genotype subjected to combined stress. E42 demonstrated a higher tolerance to water deficit compared with LA3120. Indeed, E42 was able to preserve the shoot fresh weight and to have higher shoot-root ratio under limited water availability, providing its ability to maintain high plant carbon gain. Under heat stress, and a decrease in leaf area was observed only in E42, which may indicate a tendency of this genotype to reduce water loss by transpiration. Indeed, E42 had higher specific leaf area compared with non-stressed plants in LA3120 genotype, indicated a better state of leaf hydration and higher photosynthetic activity. The imposed stresses affected negatively leaf gas exchange in both genotypes. Net photosynthesis and quantum yield of photosystem 2 were more affected when heat and water deficit were simultaneously applied. Under combined stresses, the genotype LA3120 show a decrease in net photosynthesis compared to heat stress treatment, while the genotype E42 had not a reduction. Even for the quantum yield of photosystem 2, only genotype LA3120 resulted affected by combined stress condition. In both genotypes, heat stress impaired CO2 fixation and reduced the instantaneous water user efficiency. This is an indicative of biochemical limitation of photosynthesis, including rubisco activity. Under combined stress, water user efficiency dropped only in LA3120, where E42 showed a better capacity to use limiting water resource in this condition. Another known effect of abiotic stress is an overproduction of reactive oxygen species, which leads to oxidative damage of membrane lipids. Our data showed an accumulation of H2O2 and MDA under heat stress decreases in both genotypes, and these could be considered as a marker of stress tolerance. Many studies on abiotic stresses highlight a strong relationship between thermotolerance and the capacity to increase ROS scavenging enzymes. Therefore, the activation of RPX and CAT under heat stress in E42 may be partly responsible for the lower level of H2O2 observed. Instead, activation of POD in genotype LA3120 under elevated temperature may play a key role in the response mechanism activated in this heat-tolerant genotype. To provide a broad overview of different analyses conducted on the 2 tomato genotypes in response to the different stresses applied, we make a principal component analysis. As shown in the slide, in the principal component analysis, the first 2 PCA components explain 70% of total variance. PCA clearly separated the sample subject to heat and combined stresses from control samples and sample subject to water deficit. But what are the main variables that contribute to divided stress samples? As we can see, for genotype P42, we have different variables. For example, content of total carotenoids, content of chlorophylls A and chlorophyll B, Apix enzyme activity, and specifically FERIA. While for LA3120 genotype, we have POD activity, enzyme activity, and CAT enzyme activity, and total and reduced glutathione. Instead, the mean variable responsible for different genotypes behavior are main descriptive parameter, for example, number of leaf, root fresh weight, or fruit fresh weight, shoot fresh weight, and biochemical measurements, for example, reduced ascorbic acid, content of ascorbic acid, total content of ascorbic acid, or lipid peroxidation, hydrogen peroxide content, and so on. Finally, the main findings of this work are three. Heat combined biotic stress is clearly separated the two genotypes, which employ different physiological responses in order to counteract the applied stresses, heat stress, water deficit, or combined stress. Both lines seems to be tolerant to prolonged water shortage. Lastly, the identification of novel tomato genotype E42 tolerant to heat stress in open field and even in controlled condition. I want thanks to my Professor Maria Manuela Rigano and Professor Amalia Barone and all people that work with me in the lab, Salvatore Graci, Luigia Principio, and Carmela Ezza. This picture our department in Portici, Naples. And then thank you for your attention.
Thank you very much, Dr. Silvana. Any questions? I hope there are no queries. And once again, thank you very much, Dr. Silvana Francisco.
Thank you.
Yeah. So next presentation by Dr. Klaus Wohnig from APK AG, Germany. And the presentation title is Recycling and Waste Treatment Technologies.
So can you see this?
Yes, Dr. Klaus, we can see your slides.
Okay, perfect. Thank you very much. Yeah, good morning, everybody. I want to talk briefly about recycling and waste treatment technologies. My name is Klaus Wohnig. I'm the CEO of APK, which is a recycling technologies development company. So we find out solutions for the future economy on that. Well, today, as a matter of fact, only 5% of plastics are recycled in a closed loop. And basically, I mentioned here what other technologies are available today for plastic waste. First of all, without any technology, you have unmanaged pollution. This is roughly 1/5 of all plastics end up somewhere in nature, which should not take place. 40% are going for landfill directly without any further treatment, basically. So they are just collected and brought there. And treatment in terms of plastics can mean then incineration, basically, where water of it account for that. This happens wherever this technology is available and recycling infrastructure is not really capable or meant to be there. And only 16% are collected for recycling. Basically, most of it in a kind of open loop recycling. Some say downcycling, it's mechanical recycling. Basically, I think if we want to save our world, we need to make a change from linear to circular economy. This means also in terms of plastics, collect all plastic packaging after use globally. And I tell you later on why I refer to plastics packaging in particular, because it's one of the most important streams where we need to do where we need to work on. Then we need to sort the plastics packaging in a much better way than today. To achieve better qualities and better products in a circle. And yes, of course we have to reduce littering and landfill incineration significantly. We come from 368 million tons of global plastics production, and in Europe this means we roughly have 50 million tons a year going into the market, where most of it is packaging. 40% of this huge amount is going there. Of course, there are also long-term used items like in building, construction, automotive, and so on. But packaging is more kind of short life usage, and since that is the case, we need to work on this more intensively as we did in the past, since it's really something where you can make a change easily happen if you would like to as an economy. And the mostly used polymers in there is polypropylene, polyethylene, which account roughly for 50% of the total production. There are also other materials in the market like PET and so on. But in the polyolefins, there is certainly a certain need for improved recycling. And at least in Europe, we feel already multiple tailwinds, but for the circular economy in plastics, but also elsewhere. In Europe, we tend to do this more by kind of targets, but I think this is already a global trend, and in some regions you will find either less permits to bring plastics into the market, and even some material is no longer permitted, so it's prohibited. This is what we call a regulatory tailwind, and yes, there's a raw material tailwind, so we need to set targets for the usage of recycled content. This is what's happening in some areas, and driven mainly by large brands and retailer organizations who would like to see recycled content in their packaging products again. We have a technological tailwind, means wherever there's a market available, technology will provide solutions to make it growing. And yes, you have a demand tailwind. Where does this come from? And consumer preferences for recycled materials get serious. Of course, more in the industrial countries, like because the rich people with big pockets, but also younger people have a different attitude towards environmental issues, and this is something which is certainly driving also the circular plastics economy. Business-wise, this means there are new markets growing and up. And what if you ask somebody 10 years ago, he would have thought about mechanical recycling if one thinks about recycling of plastics at This is certainly the most familiar technology in place, and it has grown up through the last 30 years. In the meantime, two other kinds of recycling come into place. One is the physical, we call it solvent-based recycling, and there's also chemical recycling. The main difference you need to know at this point is that physical solvent-based means you leave the polymer chains intact and just clean them up or split different polymers from each other. And chemical recycling basically means that you destroy the polymer chains to get monomers or pre-products from it. Yeah.
Hello, doctor. Yes. Can you make it a full screen, as we got a message from Dr. Barbara that the text is too small, that it is not visible.
I tried. Just let me check. Because on my screen, but I'm not quite sure.
Yes. Yeah. The first option. In that toolbar, yes. Yeah, that first one.
It's better now?
No. Can you please once
smaller.
go backward? Yeah. You have clicked the second one. Please click the first one first.
But this will start from the beginning, I guess. So is this better?
No. Yes. You can click the right arrow so that you can go to that
better
slide.
Now?
Yes, perfect. Yes, now you can continue.
Sorry.
For
so hopefully you got anything up to now. Sorry. Okay. Yeah. Where was I? Here I was. Chemical recycling basically brings you back to pre-products by technologies like pyrolysis or gasification. So basically you go back into elements of the period system or carbon-based and so on. So it's more going, like the word says, going back into chemistry. Good. And this shows also the past way. So in the past, we had this kind of standard mechanical recycling. It's really a mature technology, especially for PET bottles. It's already perfect. You see in the supermarkets products which are basically as new coming from mechanical recycling streams. But there are also worse products coming from there, especially in the case of polyolefins. You have always the problem of mixed materials, of multi-layers in there, where a mechanical recycling technology really cannot cope with. And so it's really not applicable for composite and unsorted plastic waste. So I think there has to be something better in place, and which gives you not only a better yield, but also a better product quality in the end. The chemical recycling, the technology really gives you a perfect product in the end, but for the price of a very low yield today, we do not have any large-scale plants in the market today. I think the first demonstration plants are coming up at let's say on kilogram level. Some like to go for tons as well, but it's really in a very early phase, I would say. But there's a substantial investment in this market. So I heard about 7 billion euros only in Europe. So it's really a huge number. And in between, there's closed loop recycling. It's a pioneer technology. It's much closer to mechanical recycling. The only thing one would see there is that you dissolve a polymer, and I will show you later how this works. And you clean it up and bring it back into a product. One of the most important facts is that chemical recycling certainly has a bad carbon footprint, while mechanical recycling, except for PET bottles, brings you not to the same quality level again. Solvent-based recycling is a kind of in between. It has a very good carbon footprint and brings you into closed loop products again. So this is why it's recognized by institutes like IFOI in Heidelberg as a very environmental friendly recycling way. And this is what APK does. We are doing this kind of stuff. So we think we are well prepared to bring this technology in the market. And in fact, we are already in the market on our own. So we have a company in Merseburg with a plant of 20 KT of capacity, and it's up and running. We have jobs of 450 people here working either in production or also in R&D, because we would like to scale up this also to other streams. We started basically in Merseburg with based on flexible packaging waste, which is not that easy to recycle, but we think our technology can really make a difference there. So we started in 2008 already. Let's have a look into the future after some learnings and so on. We finalized our post-consumer recycling technology last year, and now we provide us for an IPO. We do on scale up, and we would like to bring more than one plant in the market. So we plan for 6 to 8 plants, and yes, we can show up with a large-scale plant already, which is up and running. Maybe you're interested in how this works, though. A mechanical recycler has usually always the same concept. And I think what I'm showing here is just a short summary of what you can see also in other places. So you get plastic waste from automated sorting or manual collection. You have to shred the material, what we call size reduction. Then you have a dry cleaner in your process. Which means that you get off the material, the labels, which are mainly paper fibers. So this is something you shouldn't mix up with plastics. You have a kind of wet cleaning and fractioning. Basically, this is a kind of density separation. You dry the flake, which you create, and then you extrude it. This is what every flexible packaging plastic recycler does. In Merseburg, we have also another plant site in there, which does this for post-industrial waste, but in a different manner. Why is that? Because the feedstock we are using there is multi-layer film, and multi-layer film which is no longer be useful coming from post-industrial direct, means if you produce flexible packaging, you have this kind of cutting edges, or you have changing rolls, means whenever you change your extruder lines for a new product, you will create a lot of scrap in between. And this is, in terms of multi-layer films, it's not recyclable today, so it goes into incineration. And this is where APK can help out. We can bring it to our new cycling plant and reduce it. So we shredded this material. We fraction it, means we have to get rid of some tapes or whatever is in there, which should not go into the dissolution process. It goes then into the solution, and we have a kind of solid liquid separation. In terms of the example here, we sort between polyamide and polyethylene, and we create 2 very nice products. One goes for polyamide into kind of injection molding products like screw anchors or things like that. And the other part goes back into film and could, for instance, be used for packaging in case of baby care. So we are on a very high quality level and already working with large brands on that. And we combine these processes from time to time in Merseburg already for post-consumer waste, where we take the first step from the mechanical lines. So as I mentioned before, we reduce this material. We sort it a bit to get out polypropylene, which we do not like in our LDP stream. We have this dry cleaning, and then we have a kind of difference, which is hot cleaning, so hot washing. And fractioning and drying is, again, very similar to the standard stream. And then we dissolve the material, we clean it, so we have this kind of solid liquid separation, and And what's very important is solvent recovery. We have a very clean polyethylene in the end, and this is something we extrude and give it back into packaging. So this is how this kind of technology works, and I think there are a couple of companies working in a similar way. I'm quite confident that this will come up in the markets in the near future, as well as mechanical recycling will increase and chemical recycling will show up. So there are different recycling methods which complement the kind of facility of different waste treatment methods beyond incineration. Thank you very much. Any questions?
Thank you, Dr. Claus, for your presentation. So anyone having any questions? Okay, no questions from anyone. Thank you once again for your presence and presentation.
Thank you very much.
Okay, thank you. So now we can proceed towards the lunch break, and we will be back at 13:30. That is after half an hour. So please stay connected. We will proceed with the program at 13:30. That is at 1:30 as per London timings. Thank you. Thank you for staying connected.
This conference will now be recorded.
So hello everyone. Thank you for staying connected. So now we will start our sessions. And our first presenter after the break is Dr. Silvana Francesca from University of Naples, Federico II, Italy. Hello, Dr. Silvana. Hello. Hello, Dr. Silvana. Are you with us?
Yes, I'm here.
Yeah. Yes. Now you are the presenter. Please share your screen with us.
But I presented before my presentation.
Oh, okay. You have completed your presentation?
Yes.
Okay. Sorry. So we'll go with the next presenter. That is Dr. Olwafemi Samuel Oyamakin from University of Ibadan, Nigeria. Hello, Dr. Olwafemi. So I think he left the session. Please allow me a 5 minutes so I will contact him. I'm sorry, I tried to connect Dr. Olva Femi, but he's not lifting our call. So we will proceed with another presentation from Dr. Luca Apolloni from Università degli Studi di Napoli, Italy. Hello, Dr. Luca. Will you present now?
Yes, I'm present. Wait a moment, please.
Okay, so I'm going to make you the presenter. Yes. Yes, we can able to see your screen. Yes, you can make it a full screen. Perfect. Please continue with your presentation.
Yes, sir. Can you see my screen?
Yes, yeah. Please continue.
Oh, okay, perfect. Good morning, everyone. I am Luca Polloni, a researcher at the University Partenopei of Naples and member of the National Interuniversitary Consortium for the Marine Science. Today, I will talk about the seawater acidification effect on beta diversity, and in particular on the benthic community beta diversity that we studied in the hydrothermal vents of a marine protected area present in the Gulf of Naples, here in Italy. The presentation will be start with the presentation of the hypothesis and the study area, the environmental parameters that characterize this area, and the community that we studied in order to assess the beta diversity and the acidification effect of beta diversity, and at the end, the conclusion that we have take from this study.
Yeah, hi, Dr. Olva Femi. Yes, I'm calling from Climate Change Conference. You
Sorry,
are
what's
not the
up?
online. We have called your name, but you are not there.
Excuse me, you have the microphone open? Sorry? Okay. So, all biological systems have general properties that coherently with the environmental condition modify their structure in order to maximize the resource exploitation and tending thus to an equilibrium states. This equilibrium states in ecological field was called as a climax. In marine realms, benthic assemblages are heavily modified since sessile sedentary species passively endure environmental shift throughout their whole life. Among the extreme marine system, hydrothermal vents have a wide global distribution, occurring in oceanic bottom both in latitude and depth. Several studies reveal the occurrence of benthic organisms in the hydrothermal system is strongly related to the volcanic fluid and related to the characteristic of these hydrothermal vents, such as the concentration of iron, zinc, gases like methane, hydrogen sulfide, and carbon dioxide. In the Mediterranean Sea, very shallow Mediterranean vent characterized the coast from the shallow area to 30-meter depths. And here it's important because the most of them are characterized by carbon dioxide emissions that affect the seawater with an acidification effect that is the same that happen after as a consequence of climate change. Beta diversity is an assemblage's gradient coherent with environmental variation coming from the interaction between ecological and endemic abiotic characteristic. Small-scale heterogeneity is a measure of beta diversity and can be defined as the variation of a community composition among a set of sample without referring to any kind of any direction. In a classical Baci studies, where for the Baci we refer to the before-after control impact study, the high small-scale heterogeneity is related to low impacted area. So how much a community is heterogeneous provide an indication of its resilience capacity. Since assemblages change their pattern in space according to the environmental drivers. In addition to the resilience capacity, it's important, and to the small scale heterogeneity, it is important to assess also the species richness, since a high species richness allow for high redundancy. So if a species that cover functional traits of a system lack can be substituted by another space that have the same functional traits. So resilience capacity and redundancy is strictly related to the height community stability. In this presentation, this investigation, we ask, does high heterogeneity reflect assemblages with high resilient capacity also in acidified seawater environment? The study was located in Italy, and in particular in the Gulf of Naples, where are present is located on the Phlegraean caldera, where are present two kinds of emission. One emission that here take the name of G site, where that is characterized by sulfur emission and a white mat around the geyser, and the one characterized by carbon dioxide emission that in the present investigation is known as H sites, and is characterized by a white mat primarily composed by a bacteria called as Bejador. The other two sites was chosen for the control site, and in the present map they was called as CN site and CS sites. This area can be considered a natural laboratory for the climate change, since, as we said, the H sites with its carbon dioxide emission determine an acidification seawater effect that is comparable to the acidification coming from the climate change. So the environmental parameters that was studied in this area was primary temperature and pH that was studied in situ, and after in situ we sampled some interstitial water by a syringer in order to assess, to estimate the organic species, anions, cations, and heavy metals. In addition, by a corer, we sampled the sediment, some sediment sample in order to assess the grain size and total organic carbon. For simplicity, we divided the grain size in gravels higher than 2 millimeters for the grain size higher to 2 millimeters, sand between 0.063 millimeters and 2 millimeters, and mud, all the fraction, sediment fraction that is less than 0.063 millimeters. In this table, we can see the main results of environmental parameters. In particular, we confirm that the interstitial water and the water around the H site have present an acidification effect by the pH value. We see that the presence of environmental vents determine a bacterial map that make high the total organic carbon respect to the control site, and that we have a concentration of a less concentration of sodium and chlorium ions. In addition, we have confirmed that the G side is characterized by sulfide emissions by the presence of these ions. The community, the first community that was sampled in this area was the macrofauna, that is regard all the organisms that have size greater than 1 millimeter. The macrofauna was sampled by a lift pump and fixed in situ in ethanol in order to be sorted in laboratories and identified by the World Register of Marine Species. Results are is clear that at the two hydrothermal sites there is a drastic decrease of macrobenthic biodiversity. This can be mainly attributable to environmental condition, in particular to the presence of sulfide, high temperature, and seawater acidification. In addition, the hydrothermal fluids in these sites produce a slight reduction of water salinity measured by sodium and chlorine ions. One thing that is important to see that if in the G sites the community, the assemblage can be considered as a simplified community composed only by tolerant species. In the H sites, this community almost disappear since the presence of the acidification effect. The second community that was studied was the meiofauna. The meiofauna was sampled by a corer and immediately sliced in order to see the both the horizontal and vertical distribution of this community. The meiofauna is all the meiofauna community is composed by all the organisms that are between 0.063 millimeters and 1 millimeter. As in most studies of meiofauna, the community is mainly characterized by nematoda taxon. No significant differences among G, H, and control site was detected, but each site shows a more homogeneous distribution of taxa than in other sites, since probably the lack of some species allow to some more tolerant ones to be present. Yes, in addition, unlike the other site, site H is characterized by the dominance of predator omnivorous organisms, taxa, which can both hunt prey and graze around the sand, such as the happy goat feeders. The happy goat feeders can graze only around the sand, but while predators omnivore can both graze around the sand and hunt for prey. Thus, there is a differentiation, is a different functional aspect that are covered in the H site respect to the other site, G and control sites. The beta diversity, as we saw, that the beta diversity can be measured by as a small scale heterogeneity that finally can be measured as the distance of the replicate sample in a site for the hypothetical centroid of the polygon formed by the replics themselves. Here we can see that the H site and in general the hydrodermal vent sites are for the macrobenthic community are higher than in other sites, both for mollusca, polychaeta, and crustacea ones, while for the nematoda ones, the small scale heterogeneity is very similar for each site. Thus, the high heterogeneous macrobenthic was detected in the H site in spite of the Bashi heterogeneity interpretation. I remember you that the Bashi, so the before-after control impact studies, is characterized by high heterogeneity linked to the low impacted area. While in the extreme while in extreme environment, only tolerant species can survive, finding open niche that are normally occupied by other species. Despite the heterogeneity in the H sites, the low macrobenthic species listed confirm the loss of redundancy. So that is not true for the myobenthic assemblages that find in the macro habitat, and where we talk about the macro habitat, we refer to the habitat that is present among the grain of sediment that can find where are different conditions that in the other large-scale environment. So the myobentic can find in this microhabitat suitable environment in order to survive. So, at the first question, does higher heterogeneity reflect assemblages with higher resilient capacity also in acidified seawater environment? The answer is no. In extreme environment, as those determined by the acidification of carbon dioxide, hydrothermal vents better diversity measure is coupled by a loss of redundancies, and assemblages with higher resilient capacity are those having a life trait that allow to find normal environmental conditions for their growth, such as the microhabitat for myobentic community. From this study, we published 3 papers that you can find online, are open access paper that are very interesting because in addition to this with this presentation, we have investigated also the effect of macro and myobentic community and their beta diversity with the single environmental parameter. Thanks for your attention. Any question? Hello?
Thank you very much, Dr. Luca Apolloni. And please proceed with the questions, if any. I hope there are no queries. So if any questions, please mention it in the chat box.
Okay.
Yeah, thank you very much, Dr. Luca, once again.
Thank you. Thank you.
So next presentation by Dr. MD Mozammel Haq from Bangladesh Rice Research Institute, Bangladesh. And the presentation title is Net Global Warming Potential as Influenced by Nitrogen Sources for Wheat Cultivation in Bangladesh.
Yeah, I'm present.
Yeah, Dr. Mozammel, you can share the screen now. I have made you the presenter.
Okay. Can you show my presentation?
Yes, we can. Yes, we can see the slides. It would be better if you could maximize the screen.
Maximizing. Now it's okay?
No. Go to the slideshow, click on the slideshow. You can see in the top, home, insert, design. Yes, exactly there in that line, slideshow. After animations, you can see the slideshow. It's in the top first line.
First line, this is...
Yes, there only, slideshow.
This camera, not slide. Oh, slideshow, this camera.
Yeah. Slideshow. Just click on slideshow so that...
No. I'm trying
it's
again.
Okay, it's okay. Yeah.
Okay. Now is okay?
No, actually we are not able to see your slides. Can you open it again?
Oh, okay, again. This is shear, and then go to the shear, including sound from shear.
Yes, that's fine. If we are not able to read, we will ask you again to maximize or zoom it. You can start the presentation now. That's fine.
Okay, thank you. Welcome all of you to the online international conference on recycling and waste management under sustainable and climate change. So now I'm Dr. M.D. Mujammil Haq, Senior Soil Scientist, Bangladesh ICC Institute, Bangladesh. So today the title of my presentation, Net Global Warming Potential as Influenced by Nitrogen Source for Wheat Cultivation in Bangladesh. Do you know wheat is the second crop all over the world? It's important for food security, but problem is that some greenhouse gas produced from agricultural field. So, so, there are many greenhouse gas produced from agricultural field like carbon dioxide. Carbon dioxide is one time harmful than that of others gas, but its contribution about 60%. And another methane is 25 times harmful than that of carbon dioxide. And nitrous oxide is also 265 times harmful than that of carbon dioxide, but its contribution is about 7%. So the climate change, because there are so many greenhouse gas produced from agricultural field, that impact the increase our CO2 level as well as increase our temperature. So another problem is that the day by day increase our population but decrease our land. So and 19 were used 7.1 hectare per person, but 2050 we can use 1.44 hectare per person. So, so we need more crop or that food or that means food production. So Bangladesh also they day by day increase our population but decrease our agricultural land. So we need more food production for security or solve of the population demand. So another problem is that climate change is major threatening the food security of developing country is the main challenge. But due to climate change is about 17% wheat crop lost during all over the world, not only Bangladesh. So here you can see another greenhouse gas emission also produced from agriculture field, methane. Methane, there are so many sources. Anthropogeny is also another important source for produce methane emission. So another methane emission mechanism, how to produce methane emission. So when we apply fertilizer, after decomposing, methanogenous bacteria use this organic substance. This organic substance use methanogenous bacteria, and then therefore they have produced methane emission. But methane emission produced under anaerobic condition, but wheat is wheat crop wheat cultivation produce or plantation or sowing under aerobic condition. That's why during wheat cultivation they are produced not methane emission, they are produced methane oxidation. So another gas is nitrous oxide emission from field when we applied organic amendment or urea fertilizer after ammonium or nitrification, after that nitrate and denitrification, final products of N2O emission. So this is we have a net ecosystem carbon balance during field measurement. Field measurement scale, they are produce greenhouse gas emission. Also, they have absorb carbon dioxide through photosynthesis. So therefore, we have considered net ecosystem carbon balance. That means we have considered input carbon and output carbon. Input carbon we have considered rice straw, rice grain, rice root, rice litter, rice deposit. Also output carbon we have considered carbon dioxide carbon, methane carbon, and above ground biomass. Therefore, we have calculation how much carbon dioxide absorbed through photosynthesis. So in Bangladesh, we have, do you know, there are so many major cropping patterns are available, but among them we have considered wheat, jute, tea, almond. But today I will present only wheat crop cultivation. So uh, so to their objective to find out the methane, nitrous, carbon dioxide emission from wheat cultivation, to find out total methane, carbon dioxide, nitrous oxide flux, to find out the net ecosystem carbon balance based on carbon input or output. And another objective was to find out the greenhouse gas intensity, and last objective was to find out global warming potential based on net ecosystem carbon balance. So this experiment was installed at Bangladesh Agriculture Research Institute from Institute Farm, Gazipur, based on greenhouse gas emission, global warming potential, GG intensity, and also identify mitigation of greenhouse gas technique. So our treatment was four. One is native nutrient, that means control, no fertilizer, and another pale urea, and third one was NPK briquette, and fourth urea super granular USG. That means our crop cultivar, wheat, barley, gum, 30 we are used, and our seeding of sowing time was 25 November 2020 and 2019 and 2020. So we have used closed static chamber. Here we can see this is a white color. This is our chamber. Per weeks, one times we have gas collection. Also, we have used gas chromatography machine. So also we have used FID detector for analysis of methane emission. Another we have used TCD detector for carbon dioxide, and another ECD detector for nitrous oxide. Also we have used when we calculation FID, that times the temperature was column temperature, inject temperature was 100 degrees centigrade, 60 degrees centigrade, and 100 degrees centigrade. So we also consider the net ecosystem carbon balance. We have used GPP, gross primary production carbon, NPP, net primary production carbon, also consider for estimate of net ecosystem carbon balance. Also, we have used net ecosystem production, auto heterotrophic carbon dioxide, methane harvest, and harvest, that means above ground and below ground biomass. Liter rhizome deposit also considered for estimation of net ecosystem carbon balance. So we also used this equation for calculation of net ecosystem carbon balance. So we also used net primary production grain carbon, net primary production stroke carbon, net primary production root carbon, net primary production litter rhizome deposit, and net primary production of fertilizer carbon. This is input carbon. We also output carbon was methane carbon, carbon dioxide carbon, and above ground biomass carbon. So we have also used this equation for calculation of net global warming potential. Global potential also consider methane into 2028 and plus nitrous oxide into 265 and minus NECB, net ecosystem carbon balance. So here we can see we have considered three gases for estimation of global warming potential. Why I have used minus NECB? Because our during wheat cultivation they have absorbed carbon dioxide through photosynthesis. That amounts carbon dioxide also minus from GWP. That's why our GWP value I will show in result negative. So this is my result and discussion. Here we can see this is we have used four treatment: pill urea, NPK briquette, UG native fertilizer. During days after seeding, or here we can see about 30 DAT and 30 DAT, about 45 DAT, methane emission also high because of due to irrigation, because during wheat cultivation we have irrigated after 30 DAT, about 45 DAT. That's why our methane emission was significantly higher than that of later and later stage and initial stage. Also, same phenomena were observed 2019-20 and 2020 and 21. So this same phenomena were observed. Here we can see total methane flux. Here it is among the treatment, USG, urea supergranule, showed significantly lower total methane flux than that of NPK briquette and fill urea. So here we can see among the nitrogen sources, nitrogen fertilizer like fill urea, NPK briquette, USG is most suitable for environment because they have produced less amount of methane, total methane flux. So here you can see another gas is nitrous oxide. Here you can see the initial stage methane nitrous oxide peak was significantly higher because of application of a fertilizer, and later stage nitrous oxide almost zero due to aeration or soil moisture condition. The same phenomena were observed 2020 and 2001. Here you can see total nitrous oxide flows. Here we can see among the treatment, urea supergranule USG fertilizer showed significantly lower total nitrous oxide flow than that of fill urea. So easily we can say USG one is the important fertilizer for reduced methane emission as well as nitrous oxide emission. So here you can see carbon dioxide emission from wheat cultivation. So later stage, here you can see in initial stage methane emission also significantly higher because due to moist soil temperature was low. That's why our methane emission also higher, but uh, carbon dioxide is totally different. Upon later stage, carbon dioxide is significantly higher. Why this happened? Because of rice or wheat root biomass. Biomass volume was significantly higher, more high oxygen concentration was high. That's why our CO2 concentration significantly higher at later stage than that of initial stage. Same phenomena was observed both here. So here you can see total carbon dioxide flux. Here we can see carbon dioxide flux also. USG showed significantly lower carbon dioxide than that of fill urea and NPK briquette. So we have considered total input carbon from wheat cultivation. We know, everybody we know, agricultural field produce so many greenhouse gases, among them nitrous oxide, carbon dioxide, and methane emission. But wheat cultivation or any crops, rice cultivation, that crops are carbon dioxide absorbed through photosynthesis. That's why we have considered input carbon. Input carbon we have considered rice store, rice grain, rice litter, rice deposit. That's value, that's parameter are used for estimate of total input carbon. Here we can see USG showed higher carbon input than that of fill urea. So another output carbon also we have considered output carbon methane. How much methane carbon produced from rice wheat cultivation? How much carbon dioxide carbon produced from wheat cultivation? How much rice straw removed from wheat cultivation? That's amount, but that's parameter are used for estimated of total output of carbon. So that's why we have a calculation total net ecosystem carbon budget or balance from wheat crop. So net ecosystem carbon balance or budget calculation input in total input carbon minus total output carbon. Therefore we got this amount of value. Here we can see USG showed significantly net ecosystem carbon balance. That means that amount carbon dioxide absorbed through photosynthesis. So our input carbon is high, then output carbon is low. That's why our global warming potential is negative. Here we can see that means during wheat cultivation is more suitable more suitable for environment because our global warming potential is negative. That means that amount carbon dioxide absorbed through photosynthesis to the atmosphere. So non-rice crop, that means wheat, maize, and other crop are more suitable for environment for reduce carbon dioxide to the atmosphere. So among the treatment we can see USG is more good fertilizer for reducing GWP, or that means to reduce more CO2 to the atmosphere. So another we have calculation greenhouse gas emission intensity. We have used another formula for GHG intensity means total global potential divided total crop yield. So here we can see USG also showed a negative GHG emission than other treatment. So here we can see global potential per kg grain yield. So here you can see USG showed less amount of global potential than that of other treatment. So easily we can conclude that USG is more suitable technique for reduce global potential to the environment. So here I can see yield with the different int management. Here you can see we have used three nitrogen fertilizer. One is pill urea, another NPK brigade, and USG. USG showed a higher yield potential than that of others treatment, that means pill urea. We can now greenhouse gas emission emitted such as methane, nitrous, carbon dioxide from wheat crops. So global potential negative with different nitrogen fertilization. So another GHG intensity also negative with different carbon source. So in conclusion, use of USG for wheat cultivation can reduce about 14 to 20% methane emission, and also 90 to 9 to 14% of N2O emission, and 14 to 23% CO2 prox, and another than that of other nitrogen fertilizer. And also USG showed 2 to 14% yield improvement compared to other in fertilizer. So another important message is that under UG condition the net carbon budget value are positive. That's why the net global potential was significantly negative, indicating that during the wheat cultivation is environment friendly because CO2 carbon dioxide sequestration takes places. So in conclusion, use of UG as in source would be an effective soil management practice during wheat cultivation to have negative GWP and increase wheat cultivation. Thank you. Thank you for your attention. Have any question? Hello? Hello?
I think
Hello?
they are not listening. I don't know.
Hello?
Hello.
But
Yes,
Have you
thank you,
any
Dr.
question?
Muzammil, for your presentation. So anyone having any questions? Okay, so no questions from anyone. Thank you once again for your presence and presentation.
Thank you. Thank you.
Okay, so moving on to our next presenter from Dr. Francesca Valenti, University of Catania, Italy. Hello, Dr. Francesca.
Hello,
Are you ready
thank
with your
you.
presentation?
Yes.
Yeah, so you are the presenter now. Please share your screen with us.
Okay, I sent and prepared a pre-recorded video and sent to the organizer committee. So I will try to share the pre-recorded video. But if you have any problem with the audio, please let me know so I can start and proceed with the standard presentation.
Okay, so we can able to see your screen now. So
You
try to
can?
play the video. Yeah.
Okay, I will try. Okay, so let's start. Hello, everybody. I'm Francesca Valenti, Assistant Professor at the Department of Agricultural, Food and Environment of the University of Catania, Italy. The presentation that I'll show you entitled Application of Life Cycle Assessment Methodology for Evaluating the Expanded Clay Granulate Production by Using Different Fuels was developed with Dr. Roberto Selvaggi in collaboration with the professors Carlo Ingrao, Claudia Arcidiacono, Agata Materazzo, and Biagio Pecorino from University of Catania, and it is part of a research study aimed at investigated industrial processes for increasing their sustainability by reducing environmental impact. We believe that innovative solutions can aid reducing the dependence upon imported fossil fuel and emissions of greenhouse gases, so favoring the development of equitable, sustainable, post-fossil carbon societies. In particular, this study could contribute filling such a research gap, since it could be the first study to environmentally assess the utilization of straw not as a potential building material, but as a biofuel for production of a building material as it in the expanded clay granulate production. This highlights, on one hand, the novelty of the study and the resultant enrichment of the specialized literature and knowledge, but on the other, the need for environmental study aimed at finding rooms for improvement by stimulating innovation in such unconventional applications. Overall, the study will contribute to promotion of valorization of local resource, of product and byproducts, and manufacture of sustainable products being highly interconnected with local territories. Before starting, it is important to define the context. Cereal cultivation is one of the most important sectors in Italy, with different actors involved at all levels of the supply chain, from the upstream to the downstream sector. Cereals are the only crops that can be cultivated in rural areas, also under adverse soil and climate conditions. For this reason, the cereal sector plays multiple key roles for both development and progress of the Italian economy and society. In this regard, in the figure shows the Italian coverage of autumn and winter cereal, and it is clearly appears that in the period from 2014 till 2017, Sicily was the second largest Italian autumn show cereal grower with about 296,000 hectares invested after Apulia. 5 species are considered as autumn-winter cereal, namely durum wheat, soft wheat, rye, barley, and oat. Here in the table, a focus on cereal cultivation was reported in the same period but in Sicily. It is understood that the predominant cultivar is durum wheat, with an average surface invested equal to 96% of the regional total. Straw is obtained as a byproduct from cereal cultivation, and durum wheat straw production in Sicily ranges between 1.5 to 2 tons per hectare of cultivated durum wheat alone. Several research studies highlight that cereal straw can be used as a renewable feedstock for renewable digestion, and also for other biological processes for conversion into biogas or biomethane or electricity heat. And in addition to this, straw can be used as a fuel in direct combustion processes for generation of energy usable in a wide range of applications. However, there exists a gap in the literature with regard to sustainability assessment of straw-fired installation Therefore, this study addressed life cycle environmental issues related to a straw fiber distillation in an industrial system for production of expanded clay granulates. In particular, straw undergoes direct combustion in a rotary kiln to produce heat as required for cooking and expansion of input fresh clay granulates. The study was carried out in collaboration with a firm of the sector that operated an important change in the production process regarding the solid fluid to be combusted in the clinking step for cooking and expansion of the input fresh clay. Particularly, the firm shifted from an hard coal-based fueling system to a system providing the utilization of renewable biomasses like durum wet straw. This was possible to be done because the industrial plant is in the highland of the Sicily, which is highly invested of durum well cultivation, and thus residual biomass like straw is abundant and available. Sicily is the largest island of the Mediterranean Sea and is subdivided into 9 provinces. The unique climate pattern and the large agricultural land area make the agricultural sector one of the greatest economic resources of Sicily due to the high quality and wide variety of production. The figures show the geographic position of the city area and the localization of the firms that we adopted as a case study in this study. Furthermore, from figures, the province of Palermo, Caltanissetta, and Enna resulted with the highest production of durum wet, and the firm analyzed in the province of Enna was localized by using its GPS coordinates on a GIS map. The GIS map was then overlaid with an orthophoto imagery to highlight the centrality of the location within the durum wet growing area of the province of Enna. This central localization represents a key factor from the point of view of reducing environmental impact related to the connected system of transport and logistics. About 3,000 hectares are required to be cultivated to meet the firm requirement, and this surface was assumed to be an equivalent circulate area characterized by 3.15 kilometer radius. Considering the need for a crop rotation system according to the standard agricultural practice in Sicily, this surface area was doubled up to 6,000 hectares, which corresponds to an equivalent circular area characterized by a 4.46 kilometer radius. So to highlight the benefit connected with the considered firm being at the center of the city area, a buffer zone was used to identify the collection boundary and compute the transportation distance for supplying durum wet straw on GIS map by using the special analysis tool available in QGIS software. The study addresses environmental issues related to the usage of straw as a fuel in the process of fresh granulate clinking and expansion that represents the core unit operation for the whole expanded clay granulate production system. The study reports an LCA application according to the International Standard Regulation of 2006. The assessment was elaborated through the following phases. First one, goal and scope definition, then life cycle inventory, and the last one, life cycle impact assessment. In the first one, the goal and scope definition, 2 alternatives were considered based upon the different material used as a fuel in the rotary kiln, coal such as anthoperam and durum wet straw such as polyhoperam. The assessment was aimed at validating from an environmental perspective the usage of residual biomass like straw to be combusted for energy production as opposed to the conventional usage of fossil fuel like hard coal. As part of this phase, the functional unit and the system boundaries were defined. The functional unit is represented by the production of thermal energy as required for making 1 cubometer of expanded clay. The life cycle inventory is acknowledged worldwide to be the most consuming part in LCA, as it involves compilation, qualification, quantification of both input and output. Input represented by the resource, material, fuels, and energies used in the system investigated, whilst the output are the material emissions in air, water, and soil, as well as the exploitation of natural and also primary energy resources. In this context, since a specialized system was investigated, priority was given to the use of site-specific data that regarded both typologies and amount of dose input and output. Primary data were provided by the firm that was positively involved in the study. The last phase, life cycle impact assessment, for developing this phase, the material and energy output flows quantified in the previous phases were aggregated in a limited set of impact categories, such as midpoint categories. For this purpose, the classification framework provided by Impact 2002 in CIMA Pro 8.1 software was used. Then, impact categories were grouped into damage categories that represent the environmental compartment that are damaged by the product in its life cycle. Therefore, the phases of normalization and waking were included in the assessment as part of the endpoint approach. Here you can see the system boundaries, which were designed to include all the processes for which differences were recorded due to the change in fuel usage. In detail, the firm was founded in 1984 to produce expanded clay in Sicily. The extracted clay is left in open air from surmounts. Heat, cold, rain, and ice are all part of the initial processing. The clay is then homogenized, broken up with grinding equipment and rolling mills. Then it moved to a long rotary kiln line, which consists of 3 elements: drying kiln, cooking kiln, and cooling tunnel. The whole production site is kept under control, and emissions are monitored to be compatible with the local regulation. The expanded clay pellets are then screened into their various fractions and kept close to the plant for sealing. Only recently, in 2014, the firm replaced the hard coal with local cereal straw to improve the environmental sustainability of the process. So a new plant to grind the big baler of straw was created before the rotary kiln line. The cereal straw is ground in a mill to obtain a small fraction of matter and stored before moving to the kiln. Therefore, since 2014, the fuel mix used for the kiln has been methane and cereal straw, accounting for 20-25% and 17-80% respectively, based on the energy produced. Data were surveyed both in the ante-operam and post-operam period, so performing a total of 8 years of collection campaign. As you can see, the table reports the data collected at the expanded clay granulate production site from 4 years for the ante-operam case and other 4 years for the post-operam case. The value from this table were then averaged and adopted for the assessment. Considering the value from the previous table in terms of heat generation and fuel mix consumption, the greatest contribution is given by the solid fuel, whether it is hard coal or durum straw wool. There is the evidence of this by looking at the first table here reported. However, it emerges that gas methane contribution to both material consumption and energy generation is higher in post-operam due to the greater amounts used as the consequence of hard coal presenting a calorific value greater than straw. Also, as you can see here in the table, the distribution percentage for each of the fuel mix component as regard to both material consumption and also energy generation. All the value recorded and elaborated in also the previous table were then referred here to the amount of energy required in a production of 1 cubometer of expanded clay, respectively 1,380 and 1,490 megajoule in the ante-operam and post-operam cases. Therefore, the resulting value reported here in table were used for the assessment. Finally, all transports, including the system investigated, were accounted and were reported here in the table by using value expressed as per cubometer of expanded clay produced. As you can see in this table, we reported the transport flows related to the system investigated, and the TF stands for transport flow value, and all are expressed as a ton per kilometer per cubometer of the produced expanded clay. All data reported in previous table and also here were combined with background data then extrapolated from database like EcoInvent3 available in CIMA-Pro software. This study highlighted that the ante-operam scenario is largely more impacting than the post-operam one, and thus environmentally validated the choice operated by the firm to change the thermal energy source through shifting from hard coal to durum wet straw. In this regard, the environmental damage was 26.2 micropoint in ante-operam system instead of the 16.52 micropoint in post-operam per cubic meter of obtained expanded clay. As shown on the left figure, production and combustion of the input fuel mix in the ante-operam system, considering the amount required for 1 cubic meter of expanded clay manufacturing, contribute together for 96% of the overall damage, whilst in the post-operam system, figure on the right, the environmental damage generated by both production and combustion of about 70 kilogram input fuel mix per cubic meter of generated expanded clay contribute for a total of 94.98%. So by observing these two figures, there is an evidence that the damages from gas methane production is higher in the post-operam case due to the greater amount implied per cubic meter of expanded clay. The production of durostrom is slightly more impacting than that of hard coal. The electricity consumption is more damaging in the case of straw rather than of hard coal because straw treatment is more sophisticated and stringent than performed for hard coal, and so it is more energy demanding. Finally, the transport are more impacting in the ante-operam system, mainly due to the employment of a freight ship for supply of hard coal from Ukraine, so remarking the benefit of 0-kilometer supply chain. For clearness reasons, discussion of assessment result was extended to the damage and the impact category and the related most damaging substances emitted and the resource consumed. Figures show the hand-weight result per each damage categories in both time of system considered. It is possible to notice what? It is possible to notice that in the ante-operam system, climate change is the most damaging categories, followed by resource, human health, mainly because of the production and combustion of hard coal. Instead of in the post-operam system, the human health is the most affected damages categories, followed by climate change and resource, because of the materials, the fuels, the energies, and the activity that are involved in the durum wet cultivation. About the ecosystem quality, this is the damage category undergoing the lowest damage of all for both systems assessed in this study. However, it resulted to be more affected in the post-operam case due to the agricultural phase being on the base of the straw production. For each the most significant damage categories, a detailed assessment was performed for the substances emitted and the resource consumed that are the most representative of both systems considered. Those results were listed here in table in form of output flow inventory, characterization, and weighing. From the table, there is evidence that regarding the resource damage category in the post-operam process, the gas natural and crude oil are the most damaging primary energy source. By the contrast, hard coal is the most damaging resource in the ante-operam plant. Instead of related to the human health, the post-operam system showed the worst performance for all the substances emitted considered, mainly due to the straw production for sulfur dioxide, particulates, nitrogen oxides, and ammonia. Instead of climate change category, the CO2 emissions resulted for both the plants as the most impacting upon climate change category by generating a damage that was quantified in 15.3 micropoint and 4.93 micropoint, so highlighting the worst performance showed by the anti-operant system, mainly due to hard coal combustion. Finally, findings of previous table allow to clearly understand that the most significant and, above all, system representative impact category are those reported here in the figure, related to global warming, non-renewable energy, and respiratory inorganics. These are the most impactful impact category of the system investigated. In the table, the midpoint results were reported per cubic meter of produced expanded clay for this most impactful impact category from a comparison of the two plants layout investigated. In conclusion, innovation in the expanded clay granulate production industry in Sicily has determined a change in the choice of the thermal energy source of the process from the usage of conventional fossil fuel toward the utilization of renewable biomasses. Results indicate that higher impact is associated with the hard coal fueled plant than to the durum wet straw fueled one. In fact, this study has contributed to validating the renewable biomasses like straw as alternative fuels to decrease the environmental impact associated with the building materials production systems. In detail, durum wet straw production is more impacting than hard coal, essentially due to the greater amount used per cubic meter of expanded clay. The study supports the principle that replacing fossil fuels such as coal with agricultural residues such as straw may represent an environmental friendly method for the management of those residues and a sustainable way for conservation of fossil fuel and natural resources. Furthermore, the study highlighted that the utilization of straw in the system investigated leads to valorization of local resources based on their availability in a circular economy perspective and the manufacture of sustainable products being highly interconnected with local territories. Finally, alternative application of straw like those in the building and bioenergy sector could represent an opportunity for firms operating in agriculture to expand the range of products offered and to meet new requirements for sustainable agriculture. Those alternative applications are expected near in the future for increasing important roles that built environment and building will play in the life of humans in terms of quality, health, safety, and sustainability. So we have to try and leave our world better than we found it. This is our mission. So thanks for your attention.
Thank you, Dr. Francisca, for your presentation. So
Thank you.
anyone having any questions? Oh, I think no questions from anyone. Thank you once again for your presence and presentation.
Thank you again.
Okay, so as our next presenter has not yet attended the session, so I would request Dr. Nitesh Anipogu from Cologne University of Applied Sciences, Germany, to present her
Yes.
poster presentation. So, hello, Dr. Nitesh. Can you able to present now?
Yeah, I can present it.
Yeah, okay, thank you. So I'm going to make you the presenter. Yes. So please share your screen with us.
So are you able to see the poster now?
Yeah, perfect. You can make it a full screen or somewhat zoom in so that we can able
So
to
I've
see it
zoomed.
properly.
So now
Yeah, perfect. Yeah, continue with the presentation.
Okay, thank you very much. Yeah, Hello everyone, my name is Nitesh Babu Anepopu. I'm a PhD student from Professor Astrid Riorik. Today I'm going to present a topic called simultaneous investigation and evaluation of the deammonification process versus conventional nitrification and denitrification process in a two-lane landfill leachate treatment pilot plant. So as I mentioned in my topic, we are working with landfill leachate treatment. Landfill leachate is usually a high-strength wastewater with a high concentration of ammonium, biological oxygen demand, chemical oxygen demand, chloride, pH, heavy metals, and different components. So the landfill leachate has to be treated before we discharge it into the natural waters. There are different ways to treat landfill leachate, like physical treatment, biological treatment, and chemical treatment. Usually, biological treatment is a common practice. It is done with classical nitrification and denitrification process. But after the introduction of new shortcut pathways like simultaneous nitrification and denitrification process and partial nitrification and anamorphs process, the conventional process has been limited for the wastewaters with a high nitrogen content due to its high operational cost. In this study, we are going to develop a three-stage deammonification process, and we want to compare the deammonification process with the classical nitrification and denitrification process. For that, we have this pilot plant with a 3 cubic meter. Each lane has 1.5 cubic meter with 3 bioreactors. In lane 1, we are using the first reactor for anamorphs process, second is partial nitration, and third one is anamorphs process again. So we have the continuous recirculation between these 3 reactors. And in lane 2, we have nitrification, denitrification, and nitrification. And here also we have a continuous recirculation. What actually happens during these two processes, during nitrification and denitrification, are shown here. So in landfill leachate, we have usually a high concentration of ammonia. The ammonia is initially oxidized to nitrate with the help of ammonium oxidizing organisms. And then nitrate is oxidized further to nitrate with the help of nitrate oxidizing organism. For this process of nitrification, we need a significant amount of oxygen. And after nitrification, denitrification process takes place where we require an additional carbon source like acetic acid, ethanol, methanol, and other carbon sources. During this process, nitrite is reduced to nitrogen, as mentioned with the external carbon source. This is nitrification and denitrification process, and I will explain about the nitration and deammonification process now. In this process, a part of ammonia, what is present in landfill leachate, is initially oxidized to nitrate, and ammonium and nitrate together are reduced to nitrogen gas with the help of anaerobic ammonium oxidizing bacteria. These are a special kind of bacteria which are very slow growing and which helps us in saving the cost. Like with this process, we can save oxygen and we can also save an carbon source. So in this study, we have the following objectives. We want to determine the suitable parameters for the three-stage deammonification process, and we want to characterize the activated sludge, and we would like to enrich the anamorphs bacteria in our activated sludge. And we would like to assess the amount of oxygen and carbon that is required for the process, and we also want to see how much surplus sludge are we producing during this both processes. For that, we have following research questions. So for the long-term stability, we need to have a stable nitrogen removal efficiency, and we need to have a proper anamorphs activity. And for this process, we need to inhibit nitrate oxidizing organisms so that we have a partial nitritation instead of complete nitrification. And we also need to understand about the community analysis. In this activated sludge, we have to see how the community is, which bacteria are dominant, which microbial group is dominant. For that we have to do some community analysis. And we also need to know how will the COD influence on the anamorphs activity. Usually in landfill leachate, we have a very high concentration of COD. This might affect the anamorphs activity. So keeping an eye on COD levels is very important, and we have to maintain the proper CN ratios to have a proper anamorphs activity. And biomass retention is also very important. We have to retain our biomass in the bioreactors without a bacterial washout. So for this, in this study, we are using ultrafiltration membranes to retain the biomass in the reactors. So in this study, we have planned the experiments in 4 different phases with the reduction in the hydraulic retention time from 8 to 3 days, thereby increasing the nitrogen loading rate from 0.070 to 0.180 kilograms per day. In this, today I'm going to show the experimental results of first two phases. As we see here in these two graphs, I'm going to show the nitrogen loading rate, nitrogen removal rate, and nitrogen removal efficiency during the different phases of the experiment. Left one is for lane 1, that is deammonification process, and lane 2 is our classical nitrification and denitrification process. As we see here, during the first phase, we have...
Hello.
Yeah. Okay. Yeah, as we see here, during the first phase, we have provided 5 moles per day for the deammonification process, out of which we were only able to remove 2.5 moles per day, which showed us only a nitrogen removal efficiency of 50%. But after increasing the recirculation to 140 liters per hour, thereby increasing the anaerobic time and increasing the pH to 8, thereby increasing the free ammonia concentration to inhibit the nitrate oxidizing organism, we were able to see around 75 to 80% of nitrogen removal efficiency. And on the right side, we can see the classical nitrification and denitrification process, where we were able to see 90% nitrogen removal efficiency in phase 1 and 95% nitrogen removal efficiency in phase 2. So as mentioned earlier, we wanted to inhibit the nitrate oxidizing organism so that to have a partial nitritation instead of complete nitrification. As we see here in lane 1, we were still able to see the activity of nitrate oxidizing organism. In this graph, I'm going to show the activity of nitrate oxidizing organism, ammonium oxidizing organism, and heterotroph organisms. These experiments were done on the with the help of oxygen uptake rate test, where we can estimate the amount of or activity of ammonium oxidizing, nitrate oxidizing, and heterotrophic organisms. So in the phase 1, we have seen the activity of nitrate oxidizing organism, and thereby after going to phase 2, where we have increased the anaerobic time and where we have increased the pH to reduce the nitrate oxidizing organism, we have seen a decrease in nitrate oxidizing organism, and we have also observed there is an increase in heterotrophic organisms from phase 1 to phase 2. This might be due to the high COD concentrations in the leachate, which might have helped the heterotrophic bacteria for their proliferation. And in lane 2 on the right side, we always have a very high concentration of heterotrophic bacteria, but there was nitrifying bacteria coexistence in this activated sludge. So we didn't have any problem with ammonium removal or nitrogen removal. So we had a very good nitrogen removal efficiency with classical nitrification and denitrification process, even though we have a high concentration of heterotrophic bacteria. So coming to the next graphs here, usually during the landfill leachate treatment plant or for the wastewater treatment plants, it is very important to have the limits to stay below the limits of wastewater ordinance. According to the European Union wastewater ordinance for the landfill leachate treatment operators, they have to stay below 70 milligrams per liter. But during deammonification process in phase 1, we were not able to achieve it. We were above 70 milligrams per liter. But going to phase 2, we were able to remove almost 270 milligram per liter total nitrogen from 350 milligrams per liter landfill leachate. But there was still 10 milligrams per liter difference. For this, we are planning to still optimize the process. We want to change certain parameters so that we can enrich the anamox activity, and we have to create the suitable environment for the anamox bacteria so that they can enrich and we have a good nitrogen removal efficiency with deammonification process. But in lane 2 with classical nitrification, we were able to stay within the limits of wastewater ordinance. But based on these experimental experiments, I have calculated the amount of operational resources that I'm going to use for the complete year when I am doing with the deammonification process and when I want to do it with the classical nitrification and denitrification process. I've taken two examples here, oxygen and carbon source. So if I am working with nitrification and denitrification process, I need 1,413 kilograms per year of oxygen. If I am working with a deammonification process, I need only 174 kilograms per year. That is only 11% of the nitrification and denitrification process. Coming to the carbon source, we are using acetic acid as a carbon source for the classical nitrification and denitrification process. We need 256 kilograms per year. And if I am doing it with deammonification process, then I don't need any carbon source for the treatment. So summarizing the results from with the classical nitrification and denitrification process in the lane 1, we were able to successfully optimize it to the deammonification process. We had around 75 to 80% nitrogen removal efficiency, and we are planning to still optimize the process. And coming to the activity measurements, we have seen a higher ammonium oxidizing organisms and heterotrophic organisms, but we were able to suppress the nitrate oxidizing organisms gradually in phase 2. In further experiments, we are planning to investigate the microbial community in both lanes, and we want to see the coexistence of the different microbial species like aerobic ammonium oxidizing organism, heterotrophic denitrifying bacteria, and Anamox bacteria. And we are also planning to see the process stability, as mentioned earlier, with the lower hydraulic retention times. And we are also planning to do the experiments to see the Anamox activity at different CN ratios with different wastewaters. Yeah, that's it for today. Thank you very much for the time.
Thank you very much, Dr. Nitesh Babu. So, any questions?
Thank you.
So we are moving on to the next presentation. If any questions, please mention in the chat box. Next presentation by Dr. Gabriela Espaza Diaz from Texas A&M Agri-Life Research and Extension Center, USA. And the presentation title is Temporal and Geospatial Analysis of Potato Psyllid Incidence for Almost a Decade Long in Texas.
Hello? Hello?
Yeah, hello, Dr. Gabriela. You can start your presentation. We
Thank you
can
so
see your
much.
slides.
Okay, thank you so much. It's because I am muted. Okay, this is a potato psyllid. This is an insect that affect to the potato crop. Okay, let's go to see what is the situation about this. How can pass the next slide? Sorry. Oh my God. Okay. My computer doesn't move to another slide. How can I do? Sorry. Hello? Okay. Okay, thank you so much. Sorry for that. Okay, this project takes a long time, almost a decade, and 3 principal investigators took this survey, and the guys was Goldsby and Don Heaney, and also Vadillo Vargas. In 2017, the people invited to me to analyze all this data with a new point of view that is agroecosystem. Okay, this data is a public data, and also they published part of this data in these 2 manuscripts. The potato psyllides is an insect. This is a very tiny, has 3 phases. That is adults, nymphs, and eggs, and they grow in the leaves. And what is important for this presentation, because this insect transmit bacterium, that this bacterium affect to the plants, that in this case is potato or tomato. This bacteria is makes some symptoms in the foliar area that you can show here in this slides. When the potato is harvested, the disease symptoms is in the tuber. When you cut them, you can see the discoloration, and when you fry them, the discoloration is remarkable, but not always is a visual. The flavor of these chips can turn different and affect the market of the potato chips and other products of the potatoes. These pathogens, they spray for the world since 2 decades ago, and this is the countries that they detected this bacterium. So this is important because this is one emergency disease. This is happening these 2 last decades, and this is, we need to resolve why this happened now. Okay, many articles is studying about the why explain this situation, and this one logic reason could be the wind, and they projected that in South Texas the cells can fly to another countries, or another part of the country, excuse me, and also on other parts of the Texas, and they hypothesize that this potato has the epicenter in South Texas. That in this slide can show to you that in the Texas, that is here in this part of the United States, the people say that the psyllid can fly from this point, and in May, in May. Okay, okay. We start to survey these potato fields. This is a commercial field, but also we included one not treated potato field in one experimental location in South Texas to prove what is happening with this potato, this vector. We established a methodology that this put traps in the field. This is a yellow sticky traps. The yellow sticky traps catch all the adults around the field. But also we took leaves to see immature stages, because the adult flies and can catch by the trap, but the immature stage mostly is in the leaves all the time. So we need to see what happened in this. Okay. Now we start to study what happened in this potatoes field in the plants when it's very tiny and after, before it's harvested. This is the location that we use for put the traps, and also this is the stages that we counting the nymphs, the eggs, and adults. 1 leaf per plant. We took 100 plants per field weekly, and also we put 20 traps per field per week. Texas state has many sub-ecoregions. You can see in this map by colors. The dots, red dots, can show to you what is the fields that we examine. And this is in the north part of the Texas, in the central part, and the south. These ecoregions can explain what is the ecosystem that is in these potatoes crops and can relate it with the incidents, the potato incidents. Here we select the potatoes field was in 5 ecoregions. So this is Lower Rio Grande Valley, Texas Tamaulipas, Llano Estancado, Chinner, and Rolling Sands Plains. And this is the state of Texas. This is in the south part, and this state is next to the Mexico, and another part is in the Gulf. Sorry, I hear many noise. Okay, this is the geographical location. There's all these fields that we, the farmers support to us to treat all the fields with insecticides except the experimental field. This is the equation that we use for have the data in central points and make the projection to what happened with another points. And this is the map we were using in a special software to mine all this data. And basically is one population is determined with all the points around them. We use statistical analysis before, and after we use one specific software that is Supra. Any information about that, we can share with you if you need it by email. But this Supra takes all the data and show to you what is the projection that you see in the map. We use ArcGIS to display all these projections and also many other layers that we needed. This is for audit that how can looks the potato plant when it's infected with this insect. And this is the flower, how it looks, and this is the field when you go and visit the field. This is a raw data about how many immature can you find in the leaves, and this is the adults in the traps. This is the years that this took this survey, and this is the most in the points that is in blue points. Okay, what happened with these points? Okay, the projection of the adult traps showed this means of the population is going up, going down, going up. It's like a cycle. But what happened with immature pear leaves? in experimental field. The immature leaves, the means of the highest peak of each season show to you a projection that is increasing year and year. And what happened? What did this mean of this? Means that the potato, if is not treated, maybe the infestation could be more intensive. And this is important because this surveys help to the farmers to take a decision if needed to treat it or not, and when is treated, the field could be treated. But in this slide, you can see how is a more bigger the infestation is more expanded of during the months of the season. And this is important because the immature stages of the potato psyllids can have more adaptability to this crop, but also can show to you what happened in the ambient that is helped to this happen. This is per the raw data of the psyllid that we are talking about that in these next slices, that you can see in 2012 there are one farm that has a major peaks, and these peaks, let's go to see what is the projection of this hot spot in 2012. And you can see here in Texas, Tamaulipas, ecoregions, you can see this is the hot spot that we can determine in this particular data. And you can see the south of the north mostly have the equal levels of the potato infestation, but in the central part is the most highest infestation. And the theory or the hypothesis, mostly the psyllids could be more hot in this area, but no, in the South Texas is in the center. Maybe the migration of this potato could be the central to the north and the south. And the projection of the winds show that it's not possible that this infestation is happening just the winds. In this occasion, we can see that the ecosystem is helped to invasionize this insect pest. Here we can see the mean population in the top of the slide, that always excuse me, the same. The hot spot is in the south. The mean population is less in the north part of the state, but the biggest population also we can found in the central part of the Texas. And what happened with the less level that you can find in these states, when also the less level in this state you can find also in the north part of the Texas, and in the south part you can see less than the central. And what happened when the means the interval highest interval is in this population, where you can see in this map that also the central part of the Texas is the highest numbers of this potato. And you can see in this part of the graph where is the levels of this population. And many insect studies about the geographical temporal studies took the bioclimatic layers like temperature, rain, humidity, but we can see this is most important to all the system, the ecosystem, because the potatoes can survive around the ecosystem and affect the cultivation. And the bioclimatic layers don't explain well, and also the wind don't explain well what is happening with this population. And also all the insects can fly, but it's not necessary to fly in direction of the winds. This is the insect can survive locally, protect locally, and after migrate to the field. And this is my summary. That is, we took a lot eggs and nymphs and adults to show this data, and the highest number of the adults per trial was 45, and but all the time that this adults was 20 adults per trap. But the economic threshold for this crop is 1 adult per trap. Is when you have or get a 1 adult, the adult quickly infect many plants, and when this happens, the next insect can move the transmission of the disease, and you can have a devastated field in quickly, and also the bacteria can survive in the storage in the tuber and affect the next season. And the untreated field that was in experimental and never treated with insecticide disclosed that there are one escalating sustained of potato immaturely psyllids on the leaves. That is, that showed us that the insect treatment, the desiccation can help, but is not was the solution. We need to try another ecologic treatment for this farm that is affected by almost 20 years, and this disease is moving another part of the world that you can see. And this is the organization that took all the survey that is participate, also the farms in this location, the people open the team to the fields, and I appreciate that. And also I appreciate Ismael Vadillo that invited to me at this study. That was incredible interest. I think you can have more, all these team can have more evidence that something happened in this ecosystems. This is my information that you can took a photo of this for any question that you can discuss later with me. Thank you so much for this invitation and listening to me. Any questions? Hello. Any questions?
Hello. Thank you very much,
Hello,
Doctor.
hello. I have a question.
Yes.
Can I
Yes.
go ahead? Can I go ahead?
Yes,
Yes.
you can go ahead.
Oh, okay. Thank you. Thank you for your presentation. I enjoyed it. But I would like you to speak more about the software that you used, because I am not familiar with that. I'd like you to talk a little bit about the software so that we can look at it, especially when it relates to specialty. Okay? I don't know whether that is clear to you. Yes. You showed some part of the software that you make use of. I would like you to talk a little bit about it. Was it created for this project, or is accessible. Is it an open license software?
No,
And,
this software is free, totally free. And we can share by email and send to you the link to you download in your computer. This is a Mexican institution in Mexico that is below this software. Is very helpful. It's very easy, and also you can combine in any spatial software analysis that ArcGIS, ArcView, Arc2, anything.
oh, okay. Thank you. I'll look forward to that. Thank you.
Welcome.
Thank you very much, Dr. Gabriela and Dr. Olifemi. So next presentation by Dr. Sergio Clemente Castro from University of Huelva, Spain. And the presentation title is Pyrolysis Process as an Alternative to the Valorization of MSW Compost in the Province of Huelva, Spain.
Hi. Okay.
Yeah, hi.
Can you see my screen?
Yes, can you maximize it?
Okay. Okay. Hello, everyone. I hope you are having a good time listening to the very interesting presentation that have been shown today. I'm here to show a part of the work that Pro2Tech's team does here in Spain in a biorefinery framework to take advantage of different fractions of biomass, either lignocellulosic directly good or similar residues. In this case, the poster that I've come to present deals with the compost that is produced from urban solid waste from area near of the city of Huelva. The pyrolysis is studied as an alternative to the valorization of compost. This thermochemical process, in the absence of an oxidizing atmosphere, typically using nitrogen, is an efficient alternative compared to others, such as direct combustion, which produce heat but a huge amount of carbon dioxide, or land application in the agriculture improvement. Good production of synthetic gas, a mix of carbon and hydrogen, has been shown in this process an important source of energy and petrochemicals. To obtain the most favorable composting conditions for this waste, the activation energy is minimized through experiment using thermogravimetry and using Kissinger-Akahira-Sunosi method for calculating these parameters. Besides us, gases emitted during pyrolysis were analyzed to measure the bioenergetic potential. Therefore, the aim of the work is to verify that pyrolysis is indeed an adequate process and under what condition it has more potential to valorize compost of municipal solid waste. The raw material was selected and collected from a treatment plant southeast of Huelva to then treat in two different conditions. One of them in milder condition with 0.05 liters per kilogram and day aeration and 40% of moisture. In the other case with 0.175 liters per kilo and day and 55% of moisture. Aeration was added by compressed air and dispersed through a performance plate at the bottom of the reactors. In this case, reactors were half full 40 kilograms drums where the lost water was controlled daily and replaced to maintain the initial conditions. In this experiment, RAM 100-gram samples were collected at different points of the reactor and was performed in duplicate. The samples were carefully treated to separate the residues that could be conflicted, like metals, plastic, or stones, and the material was well sieved and weighed. The compost was characterized in multiple ways. Firstly, it was measured the moisture by drying at 105 degrees Celsius. Then organic matter and nitrogen were determined in the ready ground fraction. Before and after pyrolysis, the total organic matter was calculated by loss of ignition, and carbon was estimated dividing by 1.8. Nitrogen was measured after HELDA digestion, and finally pH and electric conductivity and, most interesting, elemental composition were also determined. To calculate the potential generated hydrogen quantities, a laboratory scale reactor was used. In this case, the reactor consists in a tube of quartz of approximately 10 millimeters of diameter and almost 1.5 meters in a temperature-controlled furnace. The samples, more or less 1 gram of compost, was introduced by means of a horizontal actuator robot during 7 minutes at 7 degrees Celsius at atmosphere of nitrogen. Then, thermogravimetric analysis was carried out in the laboratory with very small samples of the compost to observe the loss of mass during pyrolysis process and determine the activation energies using, in this case, the isoconversional method of Kissinger-Akahira-Sunose. At the gas outlet on this equipment, the thermogravimetric analysis, the absorption tubes was placed to measure volatile organic compounds. These gases trapped in these tubes were placed and analyzed using a gas chromatography mass spectrometry. Then, the permanent gas, mainly hydrogen, were collected in 1 liter Tesla's bags placed at the end of the line process of the scale laboratory reactor made of quartz. In this case, the gases were analyzed offline using a gas chromatography thermal conductivity detector. The maximum production of hydrogen was found between 3 and 5 minutes of the process. The amount of hydrogen and other gases was measured taking as reference permanent gas standards supplied by a external company, with oxygen, hydrogen, carbon monoxide, and dioxide, and methane in a matter of helium. With this, end the experiment part. And here we go with the results. The first table shows the most significant characteristics of the raw material and the compost samples, both on dry basis. Significant difference could be seen between these samples, found because process conditions affect the amount of organic matter, the grade, and the profile temperature in the drum reactors. From the organic matter, the values of the biodegradability constants were calculated, being appreciably higher in the second case. The higher the value of the biodegradability constants, improvement in organic mineralization and stability of the final components. The second graph gives the elemental analysis of the compost samples, in which it can be observed that as the composite time increases, the amount of carbon is reduced as a reference for organic matter. Regarding the pyrolysis experience in the thermogravimetric analyzer, the typical degradation zones were observed. A first phase of moisture evaporation, followed by hemicellulose degradation between 200 and 300 degrees, then cellulose degradation, and finally the extinction of lignin, which is more complex and recalcitrant of the lignocellulosic compounds. The peaks of maximum degradation can be observed in the graph of derivatives of mass loss curve between 300 and 400 degrees. And in addition, it's observed that the peaks are lower the more advanced the composting process is, since composting may increase the stability, degree of aromatization, and molecular weight of non-mineralization organic components. As there are no very clear difference between the two composting processes, it can be said that the first process is more favorable energetically, since aeration is less and marks the economy of the process. If we talk about the kinetic parameters, it can be seen in the results table that there are lower energies at lower conversions, since in the first phases, simpler compounds are degraded, such as hemicellulose and cellulose. Instead, high conversions refers to compounds more complex structures like lignin. Another important factor is the date of composting. It turns out that the activation energy are lower when the process progresses, because at the beginning, the organic material, especially cellulose, are more extensive, and as they advance, these are lost in favor of acids and minerals that destroy the structure of lignocellulose, making its degradation easier. Here, a summary of the evaluation of the potential in terms of energetic compounds of pyrolysis is shown. In this graph of hydrogen production in percentage of volume against activation energy and taking account the days of composting, it is determined that the progress of composting makes it possible to obtain a higher percentage of hydrogen, since the rupture of the material is easier. But it is observed slightly higher at its intermediate times, 20 days, than at 40 days. And in addition, with milder condition, reactor 1 is also superior. Another aspect is the activation energy, since that the lower it is, the more hydrogen is produced, which is obvious since hydrogen is obtained from the rupture of organic molecules. The easier it is to break them, the more hydrogen will be obtained. As in this last table, the most important organic compounds obtained in the pyrolysis process, mainly alkanes, aromatics, and short-chain compounds, which could give valuable bio-oils as liquid fuels, and could be observed to other heavy derivatives resulting from the destruction of lignin, mainly guaiacol, syringol, and other aromatic, more complex units. In conclusion, the development of the municipal solid waste pyrolysis process is strongly dependent on the condition of the previous composting process. While an aeration rate more intense leads to increased biodegradability, is more important parameters like energy efficiency and hydrogen production in the pyrolysis process that were substantially greater under milder conditions in composting. Thermogravimetric curves show the 4 typical pyrolysis zones and reveal similar peaks of the composition under both composting process conditions. However, the analysis of the gases produced from the pyrolysis process reveal that hydrogen increases in concentration as composite time advances until intermediate time. In this form, to improve pyrolysis conditions, composting process leads to the production of an increased amount of hydrogen by pyrolysis of the resulting compost, and also to a decreased activation energy. These effects were also observed before the end of the composting process, as maximum hydrogen production and minimum activation energy after approximately 20 days. And this is all. Some future challenge of this process is to take all this data to a pilot plan as a preliminary step to the industry. Since the university recently has acquired a pilot plan with a gasification pyrolysis reactor of about 10 liters of capacity, to continue optimizing the process. Thank you very much for listening to me. If you take some question.
Yes, good
Very much,
afternoon.
Dr. Sergio. So, if any questions, please go ahead.
Okay. Thank you for the presentation. My name again is Dr. Samuel Oyamaki. I'd like you to scroll a little bit to the experimental part, where you have the experimental part. Hello?
The experimental part?
Yes. Please scroll to that side, where you have the aeration 40% moisture.
The moisture?
Yes. It's under the experimentation or something.
Aeration?
Okay, yes, I can see it now. Where you have 0.050 L kg raised to power 1, the one aeration 40% moisture. Now, I like to ask, this 40% moisture and the 0.175 Lg kg, all right, is it a standard? If it is it a standard that is being used, or is a standard?
This is a standard, but biodegradability of the compost is in the range, it depends of the raw material. And in this case, the raw material of this municipal solid waste near of the sea.
I understand your explanation. What I'm asking is, if it is a standard, fine. But if it is not a standard, it will have been necessary to look at different levels of this moisture in line with the outcome that you're looking at. Instead of restricting yourself to 40% moisture and 55% moisture. What happens if I have 25% moisture? Do you have an explanation to that?
No, in that moment, I don't have the explanation for that.
Okay, let's go to the result part, just the side. The R1, R2, the TGA, D, yes. Now, if you look at these results, especially when you, no, the TGA, I'm not talking about the graph now, I'm talking about the estimates, where we have TDA. Please just scroll up a little bit. Scroll up. Yes, I can see alpha equals to 0.20, alpha equals to 0.90. Please scroll up a little bit. Up. Yes. Just up, not, you don't need to reduce it. Just scroll up. Just bring the R1, the compost slope, y-intercept, R square, and all that, and the energy stuff. Just scroll a little bit up. Hello? Hello?
Thank you very much, Dr. Sergio and Dr. Olifemi. Can I move to the next presentation?
Oh, okay.
Okay. Thank you. So next poster presentation by Paloma Luis Amigo from Institute of the Environment and Agriculture Research, Burkina Faso. And the presentation title is Improving Rice Yield in Moderately Salt-Affected Soil by Adapted Rice Varieties and Organic Manure in the Soro Valley Rice Scheme in Burkina Faso.
Okay, thank you very much.
You can share the screen now.
Okay, can you see now?
Yes, can you please maximize it?
Okay, no problem.
Okay.
Okay, thank you very much.
Yes.
As you said, I am Fuluma Louis Amego from Burkina Faso, from the Institute of Environment and Agricultural Research. And this work is a collaborative work between our institute and the Sheikh Anta Diop University of Senegal. We have worked on improving rice yield in moderately salt-affected soil. Let me close. I would like to add okay. So improving rice yield in moderately salt-affected soil by adapted rice varieties and organic manure in the Suru Valley rice scheme in Burkina Faso. So first of all, I would like to mention that rice is one of the staple food in Burkina Faso, and actually the demand is increasing due to several reasons, mostly due to change in consumer habit and also increasing rate of urbanization in our country. And local rice production represents less than 50% of the demand, which leaves significant margin for annual import to bridge the gap between the demand and the production. And the actual import is estimated at around 80 million euros and per year, of course. In our country, Burkina Faso, we have 3 systems of rice cultivation, and the irrigated rice is one of the most productive, but faces several constraints, mainly climatic and edaphic constraints, of course, associated with some unsustainable crop management practices and soil fertility practices. The soil salinity is one of the most constraints in some, not in all the country, but in some rice cultivation area, which is causing land degradation. For instance, in the Suru Valley, around 1,500 hectares were abandoned in 1990. So to allow farmers to grow more rice in this condition, we have implemented this activity with a global aim to develop participatory approach, combining different approved methods to fight against soil salinity. Specifically, it was to enhance salinity tolerance by rice varieties, adapted rice varieties, combined with inoculation using arbuscular mycorrhizal fungi that we received from our collaboration with the Cheikh Anta Diop University of Senegal. Also, we implemented improved rice agronomic performance with soil fertility management, combining organic fertilizer and mineral fertilizer in salt stress conditions. In terms of methodology, we first did some focus groups with farmer cooperatives in order to better know about the history of soil salinization in the area, and also to know what is the method that farmers are using to fight against this constraint in their field. And after that, we also did some soil sampling in order to complete the information we received in with cooperatives in order to choose in which farms we are developing the technologies. The implementation of technologies concerning three main technologies, as I said before. The first was the organic fertilizer composed of compost of rice straw at the rate of 10 tons per hectare. Also, our secondary factor was the inoculation with arbuscular mycorrhizal fungi that we did during the establishment of the pepiniary. And also we introduced it to improved rice varieties versus the local rice varieties that farmers are using in their local farms that is called Gambiaca. The improved rice varieties were the FKR 64 and 84. So after that, we did some experimentation in field, combining the three factors as a split plot design with a combination of rice varieties and inoculation as main factor, and using organic fertilizer combined or not with a mineral fertilizer as a secondary plots. In terms of results, we did some analysis of the interaction to see if there is a significant interaction between the three factors we are developing, but the probability were not significant. That allow us to perform the main effect of the factors. And for instance, for the rice varieties, there was a significant difference between the adapted rice varieties we are introducing in comparison with the local rice varieties, and the significant difference here, for instance, we had more than 1 ton per hectare with these varieties, the FKR 64, in comparison with the local rice varieties in salt condition. The second main factor also presents a significant difference because the use of compost associated with mineral fertilizer producing a significant increase in rice yield in comparison with the rice yield with simply mineral fertilizer. So, in terms of the inoculation, there was not a clear, there were not a significant difference between the rice varieties that were inoculated with the arbuscular mycorrhizal fungi and the other one that does not reserve any inoculation. And if we if we consider each varieties, we can find some slight differences, but the differences are not significant. So, in terms of conclusion, we can highlight that the contribution of arbuscular mycorrhizal fungi in rice yield improvement were not very clear and need further investigation in our local condition in order to find which ones of our rice varieties can be adapted with the inoculation in order to allow rice to better tolerance in salt condition. However, the association of the compost and mineral fertilizer improve the rice agronomic performance in salinity condition, and we highly recommend farmers to associate the organic fertilizer with the mineral fertilizer, mainly NPK and urea. Also, the introduction of improved and adapted rice varieties can help to mitigate the negative impact of soil salinity in to mitigate the negative impact of soil salinity of rice on rice production. So this work was funded by the African Center for Technology Studies and also the government of Burkina Faso through the national the fund of the local fund that they provide for national research called Fonds National de la Recherche et de l'Innovation pour le Développement, FONRED. Also to implement the activities, we also add the participation of the cooperatives, the local cooperatives of rice farmers that we are thankful to. So that was all I wanted to talk about this topic. Thank you very much. And if there is some comment and question, we can try to answer. Hi.
Hello.
Hey, hello.
Yeah, hello. So, any questions? Okay. We are moving on to the next presentation by Dr. Carolina from AGH University of Science and Technology, Poland, and the presentation title is Noble Metal Ion Adsorption on Activated Carbon Supported by Microwaves.
Okay, hello everyone.
Hello.
Okay.
You can share the PDF.
Okay, I'm
post
trying to. Okay,
Yes.
can you see the presentation? Great. Okay.
Yes, I can see the screen, but can you zoom it?
Yeah, I'm trying to do it.
Okay.
Okay, it's fine?
Yes, it's fine.
Okay, great. So hello everyone, my name is Karolina Kołczyk-Siedlecka, and today I have a pleasure to present our work connected with adsorption of noble metals on activated carbon supported by microwaves. In many companies connected with metallurgy, recycling of waste electronics or catalysts, or just the other companies working with noble metals, there is a huge problem of the loss of precious metals in the wastewater. For example, in Switzerland, just 40 kilograms of gold per year is going to wastewater. Solutions with a low concentration of metals ions go to the waste. However, looking on the amount of this waste, metal losses can be really high. So in our work, we propose to use the activated carbon as an adsorbent due to the price of this material, its availability, and because it's eco-friendly. We focused on recovery of precious metals from dilute solution. We use the solutions with initial concentrations equal to 5 ppm. Okay, so going to the experimental, we use the microwave reactor with a vessel made of Teflon. We used activated carbon commercially available, and we measured the change of concentration before and after the tests by MPAAS method, and we registered during the experiments the parameters like temperature, pressure, and the microwave power. And we can see the temperature and the pressure is increasing gradually during the time. Okay, and in these pictures on the left side, we can see the parameters as pressure. No, we can see the change of concentration depending on the parameters as activated carbon mass, pH of the solution, time of the adsorption experiments, and salinity. In most cases, we reached the efficiency close to 100%. Only in case of pH more acidic, we obtain lower concentration, probably due to the fact that in this pH, during the adsorption process occurs the desorption process of the ions. And also in case of shorter time adsorption, we achieved lower efficiency due to the fact the temperature and pressure increased gradually during the time, as we could see previously. And in the next series of measurements, the influence of salinity of the solution on the adsorption was analyzed. These experiments were made due to the desire to recreate the conditions similar to industrial ones. Namely, most often waste solutions containing precious metals are contaminated with other salts or metals from previous technological processes. On the right side, there are the scanning electron microscopy picture of the single granule. Single granule was a part of the single granule was removed by sandpaper, and in the same picture we can see the surface, the edge, and the cross section of the carbon. And the mapping analysis showed that all of analyzed metals are adsorbed on the surface on granules, and also looking just by eyes and the XRD analysis confirmed that the ions are reduced to metallic form and they create alloys. Okay, and just going to the conclusions. I just presented the preliminary studies connected with microwaves application during the adsorption processes of noble metals. Thanks to this modification, it was possible to achieve almost 100% efficiency in most analyzed cases. Just in case of more acidic pH, we obtained the low efficiency, so it is recommended to neutralize the solution before the process of adsorption. SAM picture and mapping analysis showed that precious metals are adsorbed on the surface and on the surface of activated carbon granules, and during the processes we can obtain during the process the ions are reduced to metallic form, and after, for example, burning this carbon, we can obtain the powder of noble metals. And as I said, there are the preliminary studies because we are working on a system, and it's a continuous flow system of precious metals recovery from diluted solution by adsorption of activated carbon. And there's the picture of the most important part of this system. I mean the sorption column filled by activated carbon, and to this column is pumped the solution of precious metals, and during the flow of the solution through the column, which is placed in microwave reactor, the ions are adsorbed, and the solution output is with lower concentration of noble metals. So then we can create the continuous system for recovery of the noble metals. Okay, so thank you thank you everyone for the attention.
Thank you very much, Dr. Carolina. Any questions? So we are moving on to the next oral presentation by Dr. Paula Christian. Thank you. Next oral presentation by Dr. Paula Cristina Oliveira from University of Trás-os-Montes e Alto Douro, Portugal. Presentation title is a non-destructive method based on a digital photography for the determination of vigor and the vegetative expression of vines.
Okay, let's share.
Dusiu, idziesz do nas spacer?
Okay, everyone is seeing my presentation, please?
Yes, we can see the slides.
Okay, so let me. Okay, I'm good afternoon to everyone. My name is Paula Cristina Oliveira from University of Trás-os-Montes de Douro. The university is around the Douro region of Portugal. There are a lot of vinewares, and we gonna present a new method that we was provided to determine for determination of vigor and vegetative expression of vines. This method is not non-destructive because they don't need to cut the vines to calculation the vigor. And I wanna start by showing you the why the vigor, because vigor is directly related to dynamics of vegetative growth of vine. If the vine, the vegetative, the rigor is big, the vegetative is very big, and the production is well big. Or I can say that production is directly related to the high vigor and the quality of vine, because if we have different vigors from one year to another, we don't have the same quality of the vine. And the vine is the longevity of vine is short if we have a high vigor, because the production is high and the plant is don't it requires more from the ground. So the traditional method is based on the cut of the sticks of the vine, and then we see the height of the sticks divided by the number of the sticks of the vine, and we found the vine vigor. So we must cut the vine and waiting for the fruit of their ability to cut the sticks. So we have a aim that was creation of a non-destructive method, but this aim project has to have some objectives. First one is that the calculation is fast. Fast in the meaning of they don't need to cut sticks, hate sticks, and then calculate the vigor. Easy of application because we have to cut the vine. We have to have qualification. So if somebody that don't has qualification to prune the vine can be able to determine the vigor. and independent of the ability of pruners, because the pruners they have few pruners in this region, and those days are all available. So the proposed method is based on a digital image, and here is a resume of in a figure of the method. First, we must have the image. So the first stage is the image acquisition. Then Regina, please get your phone. Oh. As I was saying, proposed method, first we have the image acquisition, then we must Rosina, please. Let me see if I can speak with. Okay, where I go to chat. Okay. As I was saying, we have the image acquisition. We must make the treatment digital image treatment that is to remove all the things of the image and stay with mark and sticks. Then we have to count the pixels of the sticks and the pixels of the mark. Then we found a relationship between the average area and the average weight of the stick, and make this comparison. We can process the vine vigor calculation. So and obtain the results of the vine vigor and vegetative expression. Okay, what is the vigor? Vigor is the mean height per cane. As I said before, the traditional method is made by hand. We cut the sticks, we height the sticks, divided by the number of the sticks, the height, cane total height, and then we divide by the number of sticks and we have the vigor. To find the relationship between the height and the area occupied by a stick, we have made a treatment of the image digitalized for each sticks of about 30 vines in 3 years, and we compared by scanning the sticks. We see the area of the sticks divided, and the sections, all the sections area of the sticks divided by the number of the canes. We have the mean area per cane per sticks. So we do this all 3 years of we must wait from February, because it's where the vine don't have the sticks. So and calculate if this work is during 3 years. Then what we we found? We found that the calculation of the mean wage of the sticks and the area occupied by the sticks have the identical behavior, as we can see in this figure. So we here have number of sticks, and we have in blue the weight, and in red the area. So they have the same behavior. So we must found that we see that they have some relationship because this behavior. So when we found the polynomial expression that translates the area to the bigger, we found a polynomial expression of the third degree, and this polynomial expression, when we have calculated manually and with the method, we have a correlation of 99.8%. So it's similar. So it's new comparative, and it's not tested because it's based on a digital image. So the process, what we make is a program made by MATLAB. So we take a picture with a mark just to calculate before, after we can calculate the pixel area because we know the dimensions of the mark, and then we can see the area that the pixel of the image is about. So we have the picture. We separate the picture in two different images. One has the mark, and the other has the sticks of the pine. In the image that have the mark, we account in our program, count the black pixels, and we got the area of the pixel because we know the dimensions of the mark. Then we remove all information of the image, maintaining only the sticks of the vine, and we calculate all the pixels, the black pixels in the image, and we've got the area of the sticks. By comparing to the polynomial expression, we can so translate the area, the mean area of the sticks to the mean area of the eight. So we got the bigger and vegetative expression. So step by step, it's any simple phone can take the picture. It's not necessarily a photograph more than telephone, a phone, mobile phone, a smartphone. Nowadays, everyone has a smartphone, so they can take a picture with a smartphone. Then, in the program, as I said before, is separating the mark, and we determine the pixel of the area. how divided all the area, pixels area, by the number of pixels. So, and we got the determination of a pixel area. Then the programming determine all the total, the area of total of the sticks. They remove they remove all the things that is not a stick of the vine, and then program we can see here in a blue application giving the results of one it's an example of one image, and we got the figure. The correlation is about 99.8%, as I said before. We can see here in this figure that by the polynomial we've got this figure, and the real, the traditional calculation figure is in blue. So they have they are very identical. And then here are the results of the third sum of those 30 vines. As we can see, the traditional method is a little down related to the new method, because it's this difference. It's because when we calculate the vigor with a picture, we calculate the vigor of old vine, and when the traditional method, when they prune the sticks, they don't prune here in the trunk. They prune a little more up, so it's natural that the traditional method, the vigor gives an approximate, it's not a real number, it's approximately, it's the real is given by the new method, because they count to the whole area of the stick vine. This work results in a Portuguese invention patent with the number of 105,163. And I don't know if you have some questions. Thank you for your attention, and if you have any questions, I'm here, or give me the feedback. This is my email. You can ask whatever you want. Thank you.
Thank you, Dr. Paula Christina. Any questions? So moving on to the next presentation by Dr. Oluwafemi Samuel from University of Ibadan, Nigeria. And the presentation title is Modeling the Above Ground Biomass of Selected Tree Species in Nigeria.
I am trying to share my screen.
Okay.
Sorry, the PowerPoint is loading so that I can share. Okay, is it showing?
No, we cannot see your slides. Open the PPT first and then click on the share screen.
Yes, I know what to do. I already did that. Okay. Okay, nice. It's on. Share screen.
Hello.
Hello, it's loading. Please
Okay, okay.
share.
Loading.
Okay, it's asking me to open system preference to grant permission. To go to. Yeah. Okay. Sorry, MacBook can be very funny at times. That's what is happening. This is the about the first time I'm using GoTo, so it's asking for some permission. Okay, I think I'm good now. Yes. Sure. Yes. Okay. Okay.
Solva Femi?
Yeah, I'm with you. I'm trying to share the screen. It's asking me for
Yeah.
some
Yes.
setup
So
on
can I? Yeah. So what is the issue you are facing?
the issue I'm having here is that I can see the screen sharing. It says screen sharing requires permission to capture your screen. Please
Yeah,
open
we
system.
have already given you the permission. You need to give system preferences permission. Are you using a MacBook or a
Yes, I'm using
Windows?
a MacBook. I'm using a
Okay,
MacBook.
for MacBook, for you, then you need to give extra permissions to share your screen in your system preferences.
Okay.
Yeah.
That is what I've just done. So
But we cannot able to see yes.
I'm expecting the sharing screen to disappear, but it's not disappearing.
No, it's not appearing.
After I already activated it.
Yeah, otherwise you can do one thing. You can once close the system and again log into that. You can try with that.
Oh, okay.
Yeah, hello, Dr. Olawefemi.
Yes, I'm here.
Yeah,
I'm,
so is it
I'm
possible
not
for you
seeing
now?
that thing.
Yeah, otherwise you can do one thing. Can you share your presentation with us in the WhatsApp or in
Okay,
the email so that I will share my screen and you can start explaining from there.
okay, that's fine.
Yeah, you can send me in the WhatsApp.
Okay.
Okay.
It's shared in your email and WhatsApp now.
Yeah, please share in the WhatsApp so that it will be easy for me to download and share the screen.
Okay. Okay, I've sent it there now.
Yeah, in the WhatsApp.
Hello?
Yeah, hello.
Yes, on your WhatsApp.
I didn't receive yet.
Okay, it's attaching. I think it's attaching.
I'm sorry.
It's getting attached to your WhatsApp.
Okay, attaching. Okay, fine. Okay, we'll wait for that.
You should have seen it by now.
Yes, I received the just for allow me for 5 minutes. I will download in my system and will share the screen. Yes, I got your slide. Now I will share my screen. So once you say that
Okay.
to change the slide, we will change the slide. Okay.
Okay.
Yes. So can you able to see my screen?
It's not loading yet.
Yeah, it is in a full screen mode. Can you able to see that?
It's coming in now.
Yes. So you can start your presentation and let me know when I have to change the slide. Okay. Hello. Hello. Hello.
Hello? Can I go ahead? Hello, can you hear me now? Is my voice audible now? Is it audible? Can you hear me now?
Yeah. So
Hello?
yeah. Hello. Is my screen is
Yes.
visible?
Yes, can you hear me now?
Okay. Yes. Yes. We can
Yes,
able to hear
this
you.
is fine.
You can let me know when I have to change the slide.
Okay. Yeah, good afternoon, everyone. Uh, my name is Femi Oyamakin from the Biostatistics Unit, Department of Statistics, University of Ibadan. And I'll be talking about modeling the above ground biomass of selected tree species in Nigeria. And let me give you a motivation before I proceed, so as to give the general background of the study. You agree with me that deforestation project has failed because of the overdependence on trees. The concept of deforestation is that when you cut down a tree, you plant another tree to replace the tree that has been cut down. But most times, we often forget that cutting down a 100-year-old tree and planting another one is always a difficult task because you wouldn't wait for another 100 years before the newly planted tree is harvested. And this is why it is very, very important. And that was what led to the introduction of the RED Plus. And in RED Plus, what has been suggested is to now encourage conservation of these tree species so that you can earn some form of carbon and you can now trade with it, which is seen to be a strategy that can make us in Africa to conserve our forests. Now, the next slide, please. Next slide, please. The next slide, please. The next slide contains the outlines of what I intend to talk about. First is to characterize the problem. This will be done through some form of interventions that we have had in terms of data visualization and dissemination. Of course, the modeling approach will also be discussed in order to understand patterns and projection. Then we conclude. Next slide, please. What I have on that what I have in this slide is a picture of a reserve in Ibadan, Nigeria. Okay, I call it an overview of Alalubosa watershed area in Ibadan between 1968 and 1990. This used to be an established plantation, and if you look at this diagram very well, you will see Cassia siamia, you will see Tectona grandis, you will see Melina arborea, you will see, Trypocatton ethereum, you will see Pinus carabia, and some of these wonderful tree species were in this plantation. But what has happened to this area? Now, let's go to the next slide. The same plantation is what I'm sharing with you now. If you look at the next slide, you will see what has become of the plantation. This is as of 2013. It has become fully residential. All the Cassia siamia, all the tree species that used to be here are gone. Okay? And this is what we are talking. We're talking about the number of carbon that is being able to that this forest reserve can trap. The trees that are supposed to do this for us are no longer there. Now let's look at the next slide. And this is talking about our carbon sequestration process in Nigeria. When we talk about the terrestrial sequestration, we talk about the power station where CO2 is captured and separated. We talk about the unminerable coal beds. We talk about the saline formation, enhanced recovery, depleted oil and gas reservoir, and the ocean sequestration. Now, this is what we know here. Okay, and this is why it is of interest to us that if this strategy can be implemented here in Africa, it will help us further to conserve our forests. Let's go to the next slide. Now, the next slide talks about the view of tree height measurement by theodolite at DBH. This is how trees are measured, especially when you need an approximate value for the height. Okay, we have here that considering the angle ACB between the tree top and the distance B at the point of observed at DBH. Most forest researchers will measure at 1.3 meter breast height, okay? And the tree height will then be calculated. Now, but that is not where we are going. We know that we have forest inventory. We have the height measurements. We have the DBH measurement. So what are we planning to do with all these things? Let's go to the next slide, please. The next slide. The next slide, please. Yes, no, I'm talking about the next slide now, where we have the next slide, please. This is where we talk about the softwood and hardwood, and how well the view of their carbon distribution in a tree. Now, we give an example of how a tree is. We have the crown, we have the backlog, we have the back, we have the stump, we have the roots. And the amount of carbon that is stored in trees, it depends on the number of things, which include the tree species, the growth condition in the environment, age of that tree, and the density of the surrounding trees. Next slide. Now, we have some generalization. Under this generalization, we know from literature that 35% of the green mass of a tree, please, no. Let's move a little bit back. Where we talk about the 35% of the green mass of a tree is water. So 65%, okay, of this tree we're talking about is solid dry mass. 50% of the dry mass of the tree is carbon. 20% of this tree biomass is below ground level in root. So a multiplication is used here. Multiplication factor of 120 is used to determine the equivalent amount of carbon dioxide, and the carbon figure is multiplied by a factor of 3.67. Now, I don't want to bother you with how these computations are done. Okay, there is a paper we wrote on carbon sequestration using probability distribution. Some of these computations are well stated in that paper. Next slide, please. Now, here we talk about the relative activity contribution to deforestation. These are what we have identified as factors that encourage deforestation here. Now, we have the commercial logging, we have the clearance for sustenance agriculture. Of course, you see a development in urbanization, which is, a negative development when it comes to conservation and sustainable environment. Now, we talk about cattle ranching, we talk about other anthropogenic activities like construction of dam, road, mining, plantation, and of course, bush burning. Now, the next thing we talk here is, because we are talking about modeling this above ground biomass, what are the candidate model that we are looking at? We're looking at 5 of them. We have Albish, that is 1977, that is expressed there as exponential of minus A plus B ln D square times H times C. Okay, then we have the brown. We have the brown moist. We have the brown model for moist. We have the brown model for wet. We have the Che moist and wet. Then we have the Basuki model. Now, here we're talking about, of course, exponential is just it's a function in mathematics where we have raised to power of a particular constant. Y is the above ground biomass, as we soon see, is measured in kg. Then we have the H, which is the height of the tree. You can go to the next screen, please. Next slide, please. Then we have the D, which is the diameter at breast height. Then we have the A, B, C, D, and E. Okay, which are the scaling parameters that are meant to be estimated respectively. Now, moving forward is the next slide, please. Moving forward is the summary, the exploratory data analysis that we have done on the 8 different species that we are looking at. Okay, and we have done this to compute the mean standard deviation, variance skewness, and kurtosis using the projection that we have obtained from these 5 AGB models. Now, if you move forward, towards the first 3 slides, you will see the summary of the statistics of the stand that we have considered in this study. Okay, we have for Bombax, we have for Melana Arborea, we have for Kaya G, then we also have for Kaya Senegalesis, we have for Mansonia, we have for Penos Caribia, then we have for Shoria, and we have for Terminalia superba. Okay, now if you look at this, these are the exploratory to give an insight of the variable that we actually, the 3 stands that we're actually considering for this study. The next slide, where we have the summary of the estimated parameter, okay, gave the estimated parameter for each of the models that we have considered. Next slide, please. Next slide, please, to the summary of the estimated parameter. Next slide to the summary of the estimated parameter computed by the allometric models. Okay, there we'll see Bombas as the first one, where we have parameters A, B, C, D. Please, next 3 slides, please. You can scroll to the next 3 slides so that we have the estimated parameter that is computed for each of these models. Okay, we have for AVES. AVES is a 3-parameter model, and we have 4.935, 0.944, 9.623 computed for the estimated for parameter A, B, and C. And shape, moist and wet is a 5-parameter model. We have the estimated parameter there, and we have for brown, moist, and wet, and we also have for Basuki. Of course, Basuki is simply just a non-linear model that can be log linearized. Okay, so it means that it can still be, OLS can be used to estimate the parameter of the Basuki model, as we will so far. Next slide, please. Next slide. Next slide, please. So we'll see the same result of the estimated parameter that is computed for the allometric model for the 8 species that we have studied. Okay, for the 8 species that we have studied, up from Bombax to Terminalia superba. Okay, now, okay, thank you. Please, I have moved forward to the estimated parameter. You can scroll forward, please. The next one that I will be talking about is the graph of the descriptive analysis that is showing the average diameter at bedside and the height, including the sample sizes of the individual tree species that we consider. Now, this is considering is actually presenting the bar chart of the stand that we have considered. And if you look at this stand, you look at it that we have quite a number of Bombax. Okay, Bombax has the highest sample size in the 8 tree species that we consider, with Kaya G having the least in terms of the sample size. But if you look at the number of the average height and average DBH, you look at what we have for Bombax. Bombax has even though Bombax has the highest sample size, we had in this study the smallest average height from the same Bombax. I'll move next to the next chart. Please, you can move to the next graph, please. This graph shows is the graph of the descriptive analysis showing the mean variance and standard deviation of the average observed AGB of the 8 selected species. Now, what we have done here is to see the variability across within the data in terms of the spread that we have noticed within variance and standard deviation. And that has been presented in a chart here to show how this species, how they vary, the level of dispersion that they have in terms of the spread. We have the same displayed under the graph of descriptive analysis showing the skewness and kurtosis of observed AGB of the 8 selected tree species. Okay, please, you can move a little bit forward. I'm 2 graphs above you. Okay, I'm 2 graphs above you, please. So you can move to the next graph where we have skewness and kurtosis. Next graph, please. Next one. Next graph, please. Next graph, please. Next graph, thank you. So here we are talking about a graph showing the skewness and kurtosis, for the observed above ground biomass. And here, looking at the skewness and kurtosis of the observed AGB, we still discover that in terms of kurtosis, Bombax seems to be highest here among all the 8 selected tree species that we are looked at. Okay. Then in terms of the skewness, the same pattern is also witnessed. Now, looking at the next one, because of my time, we also have the mean AGB plotted, where we have the predicted variable against the mean AGB. As highlighted before, we have the mean AGB, we have the harvest model prediction, we have the Brown model moist predicted, and we also have the other 5 models that we have considered. Now to the conclusion. Okay, we have seen from this study that the composition of the above ground biomass will be a useful step in the implementation of the RED Plus program in Nigeria. It gives you a better assessment to conserve that tree instead of selling the same tree to loggers. Now, on the basis of the skewness for the average observed AGB, all the 8 tree species were positively skewed. And we also noticed on the basis of the kurtosis for the average observed AGB that the trees within the negative kurtosis were Melina, Kaya, Grandifolia, and followed by Pinus Cariba. Next slide, please. Next slide, please. Thank you. Now, in conclusion, you can go to the next slide. In conclusion, please, the next slide. The predicted allometric models presented in this study, for quantifying the above ground mass of the 8 selected trees using the least square parameter estimate derived from the Marquardt algorithm, were discovered to be species specific and should significantly improve capacity to accurately estimate biomass and carbon sequestration in Nigeria terrestrial ecosystem. And it is on the basis of this that we have now concluded. Thank you for listening. Next is my references. Thank you.
Yeah, thank you, Dr. Olwafemi, for your presentation. So anyone having any questions? Okay, no questions from anyone. Thank you once again for your presence and presentation.
Thank you.
Yeah, and I would like to thank all the attendees of today's webinar for making it a successful day one webinar, and hope you will all enjoy the tomorrow's sessions too. So we'll be waiting for you. See you tomorrow. Thank you and have a nice day.